Hello everyone, and welcome to this DevOps and Cloud Computing Full Course 2022 by Simplilearn. DevOps and Cloud Computing are two of the most popular technologies in the industries, helping software development teams improve their production efficiency. Organizations have realized the need to develop an integrated functioning model which leads to development of the DevOps methodology. DevOps aims for continuous integration and faster delivery of software. On the other hand, cloud operations also call for continuous operations and improvement, but in the cloud environments. Cloud computing platforms are designed and built in a way that allows them to take full advantage of all DevOps methods. The cloud provides tools for centralized deployments and can offer support for DevOps. For example, if DevOps teams need to assemble the components for a solution in a specific way, the advanced automation capabilities of the cloud can streamline the process and make it more repeatable. Now, as per AlliedMarketResearch.com, the global DevOps market size was valued at $6.78 billion in 2020, and it is projected to reach $57.90 billion by 2030, registering a CAGR of 24.2% from 2021 to 2030. According to Statista.com, the worldwide public cloud computing market continues to grow and is expected to reach an estimated $482 billion in 2022. This encloses business processes, platform, infrastructure, software, management, security, and advertising services delivered by public cloud services. DevOps and cloud are likely to become all-rounder, and organizations will need greater discipline to craft and adhere to a strategy that leads to stability and consistency. With that being said, let's look at the agenda for today's topic on DevOps and Cloud Computing Full Course in 2022. So first, we'll understand the basics of DevOps and look at the DevOps lifecycle in detail. Next, we'll move on to understanding the basics of cloud computing, and we'll explore the different cloud computing benefits as well as the cloud providers. Next, we will understand the difference between AWS, Azure, and GCP cloud platforms. Moving forward, we are going to look at the different DevOps tools that are available, and finally, we'll explore AWS, Azure, and GCP in detail. Now let's get started.
Meet Tim. Tim builds a robot in his lab, a climate-controlled and pollution-free environment. Once he's done, he drops the robot off at his project partner Mia's house. Mia takes it out to her backyard to ensure that the robot meets the requirements. But here is where the problem arises. The change in the environment causes the robot to malfunction. Mia is now really annoyed and she has a lot to correct. And it seems to her as though Tim didn't really do much. This wall between them leaves the poor robot to bite the dust. Well, what if we broke this wall? Tim and Mia now work together in a common space. Tim develops each block of functionality of the robot, which is then immediately checked by Mia. Both are now working simultaneously instead of waiting on the other to finish their task. As and when a feature is ready for use, they are put together to build the final product. They develop a common mindset and share ideas. To further speed up the process, they use several tools which can automate every stage. This means that the robot is now ready sooner with less iterations and manual work. From an organization perspective, Tim would be the developer while Mia the operations. Their union is the core of the DevOps approach. DevOps has several stages and set of tools to automate each of these stages. Let's have a look at these. Tim first puts down a plan. In terms of software, this could mean deciding on the modules and the algorithms to use. Once he has the plan, he now codes the plan. With tools such as Git, Tim has a repository for storing all the codes and their different versions. This is called version control. Next, this code is fetched and made executable. This is the build stage. Tools such as Gradle and Maven will sort this out. Now before deployment, the product is tested to catch any bugs. The most popular tool automating testing is Selenium. Once the products are tested, Mia must deploy it. The deployed product is then continuously configured to the desired state. Ansible, Puppet and Docker are some of the most common tools used that automate these stages. Now, every product is continuously monitored in its working environment. Nagios is one such tool that automates this phase, and the feedback is fed back to the planning stage. And finally, we have the core of the DevOps lifecycle, the integration stage. Tools such as Jenkins is responsible for sending the code for build and test. If the code passes the tests, it's further sent for deployment. This is called continuous integration. Let's now have a look at an organization that has adopted the DevOps approach. Which of the below sequence of steps would they follow to develop a software? Leave your answers in the comment section. Keep an eye out for the right answer on the comment section or our YouTube community. Giants such as Amazon, Netflix, Target, Etsy, and Walmart have all adopted DevOps and seen a considerable increase in delivery and quality. In 2014, an hour of downtime for Netflix would cost it $200,000. It became absolutely crucial that Netflix prepared themselves for any sort of failure. And so, they took to the DevOps approach and implemented it in the most unique way. They developed a tool called the Simian Army. This tool created failures and automatically deployed them in an environment that did not affect the users. The team would troubleshoot these failures, and this gave them enough experience to deal with any degree of collapse. With everything being automated and happening simultaneously, organizations can now deliver at a much faster pace. So, considering the benefits of DevOps and its divergence from the traditional methods, would DevOps be the future? Let us know what you think in the comment section below.
Hello, this is Matthew with Simplilearn, and today we're going to introduce you to DevOps. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis, and this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all of this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. but then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team, and then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another point here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site.
Let's go ahead and start with this session on top 10 reasons to learn DevOps. So, what is DevOps? DevOps is a collaboration between the development and operation teams which enables continuous delivery of applications and services to our end users. Before DevOps, there was a lot of communication gap between the development and operation teams. The code that used to work fine on the development side would create a lot of errors on the operation side. This in fact led to a lot of issues. The biggest issue was the delay in project delivery. The solution to this was DevOps. In DevOps, the operation and development engineers participate together in the entire lifecycle, from the design through the development process to the delivery of the software to the end users. It enhances the process to deliver the software faster and a software of high quality. If there is any bug or error, it is fixed at the right time rather than dragging it to the last phase. Let's now look into the 10 reasons why you should learn DevOps. So at number 10, we have technical, cultural and business benefits of DevOps. Let me explain each benefit one by one. So first we have the technical benefits. Continuous software delivery is the most important process of delivering the software in smaller increments to ensure that the software can be released at any time. With this approach of DevOps, the team will always be ready on delivering anytime. It has the benefit of having less complex problems to fix. The code is tested at every stage and both the development and operation teams make sure that the complexity is reduced to a great extent. DevOps also has the benefit of faster and easier resolution to every problem. If any bug or error is found at an earlier stage, it is fixed and then moved on to the next stage. Hence, this way at the final stage, there will be zero or minimum number of bugs. Moving forward, let's look into the cultural benefits of DevOps. The workload is divided equally between all the employees, so no individual is under the pressure to code, test, debug an entire software. This results in a team that is happy and more productive. Since DevOps is a collaboration between the development and operation teams, if any issue arises on one side, the team is always ready to help. And the employees are engaged to make sure that the software is as the end user requires and hence is delivered at the set date. DevOps helps in increasing the professional development opportunities. Finally, let's look into the business benefits of DevOps. The basic principles of DevOps, that is automation, continuous delivery and quick feedback cycle, aim to make the software development process faster and more efficient. Being an extended version of agile methodology, DevOps ensures that the complete software development lifecycle goes smoothly. By promoting collaboration between the teams, DevOps offers continuous feedback so that the errors are fixed in time and the releases are done faster. These days, the development teams need to break down the interdepartmental constraints and collaborate, as well as communicate in a dynamic, round-the-clock environment. DevOps gives a way to improve the business agility by providing an environment of mutual collaboration, communication, and integration across the various teams in an IT organization. All the team members are responsible for meeting the quality and timeline of the software deliverables. With DevOps, organizations can improve the deployment frequency, recovery rates, and hence result in a lower failure rate. With every new release, it is possible to ensure the reliability and stability of an application. When applications perform flawlessly in the market, organizations reap the benefits of greater customer satisfaction. At the 9th position, we have work with good developers. Poor code is all too common. Sadly, users arrive at the realization when it's too late. The fact is, some developers are good at what they do, while others have poor coding skills. A team of software developers consists of excellent, good, average, and poor developers. It is important that the bad codes generated by many developers need to be stopped, else it may increase the production time. DevOps helps in reducing the bad code limits, as the bad code cannot go to the next phase until it is fixed. Also, a team member who is terrible at coding could be good at any other different roles and vice versa. Retasking team members earlier in the process prevent wastage of time and resources. So, in this way, DevOps eliminates bad developers and ensures that the team comprises of good developers. Next, at 8th position, we have increased efficiency. Due to increment in efficiency level, it results in speeding up the process of development and also makes it error-free. DevOps can also increase efficiency through automation. There are many ways to automate tasks in DevOps. DevOps allows engineers to focus on those tasks which are not automated. There are certain tools of acceleration that increase the efficiency. They are the cloud-based platforms or other scalable infrastructure which help in increasing the access of the team to the hardware resources and hence speeds up the process of testing and deployment operations. With the use of build acceleration tools, the code compiles faster. They may be a process that helps in embedding parallel workflows into the continuous delivery chain so that the delays are avoided. Moving on, at 7th position, we have a better organizational culture. With the help of DevOps, there has been an improvement in software development. The development and operation teams are more focused on performing together rather than having separate goals. The team is more focused on production. If both the teams are combined, it will result in innovative ideas in a very efficient and effective manner. There is improved collaboration and communication between the team members. DevOps facilitates better understanding among the team members, and this understanding increases worker morale. Next, at the 6th position, there is faster release of software. It is true that DevOps makes the process of software development agile, hence it leads to the timely release of the software. Companies can quickly study the behavior of users and incorporate the changes to come up with a better product. This, in turn, helps the organization to stay competitive. There is a reduction in rollbacks and failure rates regarding deployment and the time that is taken to recover with better products. DevOps reduces the time for cycles of development and also ensures a faster rate of innovation. At position 5, we have better knowledge of software delivery lifecycle. Once you get to know about DevOps, you will get a lot of information about the software delivery lifecycle. It is divided into main phases like planning, analysis, design, implementation, testing and integration, and maintenance. In the plan phase, initially there should be a plan for the type of application that needs to be developed. Getting a rough picture of a development process is always a good idea. In analysis, a detailed study of requirements is done to check whether all the requirements are available or not. The list of all the requirements like human resources, hardware, software required to accomplish this project successfully will be clearly analyzed and listed out here. In the design phase, the whole project is divided into modules, each module into submodules by drawing some diagrams using unified modeling language. A pseudocode will be prepared at this phase. In the implementation phase, the application is coded as per the end user requirements. Coder now has the task to do the coding. Developers will develop the actual source code by using the pseudocode and following the coding standards. The testing and integration phase is the most important step of the application development. Here, the application is tested and rebuilt if necessary. The multiple modules of codes from different programmers are finally integrated into one. Then finally, the application is developed and delivered to the end users. The final phase is maintenance. Once the client starts using the developed software, then the real issues start coming up. In this stage, the team is required to fix the issues, roll out new features, and refine the functionalities as required. At the 4th position, we have boost product quality. The concept of DevOps does not allow mistakes in the stage of methodology. When both the operation and development stages are done correctly with no errors, then it will result in a release of better and improved product qualities. This leads to a cleaner, more efficient code and hence increases the software quality with each release. The DevOps process brings better quality to the development process and reduces the chances of unplanned work. At the 3rd position, we have exposure to trending technologies and advanced tools. DevOps works with a variety of tools. Few of them are Nagios, Chef, Docker, Git, Selenium, Puppet, Kubernetes, Ansible, and many more. You will get a chance to understand and use all these tools and learn how to design, develop, deploy, and maintain an app or software with the help of these tools. Apart from that, by knowing all things about such software and tools, you can increase your chances of getting hired by the best companies. At the 2nd position, we have increase your professional credibility. By obtaining a DevOps certification, you can increase your professional credibility. This certification will help you to let the others know that you have sufficient skills in monitoring a software's performance, easily write and code with scripts, enhancing the software's security to a greater extent, providing the best IT hardware. You will be able to troubleshoot various issues in the software, and finally, you will be able to connect softwares, databases, and much more to ensure effective functionality. 42% of companies are now preferring open source jobs and want candidates with DevOps skills. So, if you want to become a part of developing the DevOps job market, then this is the perfect time to start getting DevOps training. And finally, the top reason to learn DevOps is to get a perfect job and increase your salary. DevOps is a very popular career choice now. Researchers have also shown that in the coming years, DevOps will be the main hiring criteria for 46% of the IT companies. However, they are not sufficient experts who can match the requirements. That's why there are massive opportunities for candidates seeking DevOps jobs. Besides, when it comes to salary, you can earn a lot of money. On an average, a DevOps professional gets a pay of $99,604 per annum in the United States, and a DevOps professional in India gets an average salary of 6,02,000 rupees per annum. Now, let me recap and call out all the 10 reasons for learning DevOps once again. At number 10, we had the technical, cultural, and business benefits of DevOps. At number 9, we had work with good developers. At number 8, we had increased efficiency. At number 7, we had a better organizational culture. At number 6, we had faster release of software. Then, at 5th position, we had better knowledge of the software delivery lifecycle. At the 4th position, we had boost product quality. And at 3rd position, we had exposure to trending technologies and advanced tools. At the 2nd position, we had increase your professional credibility. And finally, at the top position, we had get a perfect job and increase your salary. Now, let me tell you how Simplilearn can help you learn DevOps so that you can start your career in it. So guys, this is the official Simplilearn website, and I'm going to show you the different types of DevOps courses Simplilearn offers. So first is Devops Engineer. Let's go ahead and look into that. This is a master's program and it has 7+ real life projects. You can see the course curriculum here, that is Git and GitHub training, DevOps certification training, DevOps on AWS, and more. You can see the learning objectives. The tools covered here are Maven, Ansible, Chef, Puppet, SaltStack, Apache, Jenkins, TeamCity, and many more. You can see the course curriculum and you can see the electives that you can choose. Okay, let's go back and look at another certification. We had the DevOps certification training. So here you have 56 hours of blended learning, over 10 industry projects with integrated labs, 24 hours of live demos, and you have flexibility to choose the classes. The skills covered are DevOps methodology, version control systems, continuous integration and deployment tools, and Jenkins, TeamCity, Maven, and many more. So you can see the benefits here, the annual salary of a DevOps professional, the companies that are hiring DevOps professional. Then we can see the course curriculum. We have Introduction to DevOps, version control systems, continuous integration, continuous deployment. Then we have software and automation testing frameworks. We have containerization with Docker and much more. And you can see the various tools that are involved in this. Then we have our industry projects. So guys, in this way, Simplilearn can help you get a DevOps certification.
Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below. Coming back to cloud computing, some of the most popular cloud computing services in the market are AWS or Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Want to learn more about them and how they differ from each other? Click on the top right corner for an analysis of how these service platforms are different from each other.
Hi there, I'm Sam from Simplilearn and I work as a multi-platform cloud architect and trainer. And let me welcome you to this learning video called What is Cloud Computing? Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database, and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing, and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing. And he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. What is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Service and Microsoft Azure. Now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If you want an IT resource or a service now with cloud, it's available for me almost instantaneously, and it's ready for production almost the same time. Now this reduces the go live date, and the product and the service hit the market almost instantaneously compared to the legacy environment. And because of this, the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all these 6 sort of stand out, categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private, is it public, or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the service the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network, storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications, and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on a subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the four models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resource managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. There are lots of famous well-known organizations around the world. They have moved or have migrated to the cloud environment. Pinterest is one company which is one of the world's largest visual bookmarking tool with more than 70 million monthly active users. Now Pinterest was able to scale its business because it was all built on Amazon Web Services. With a company with less number of employees, Pinterest decided that they do not want a dedicated staff time to manage a data center. Instead, Pinterest uses AWS, or they used AWS to manage their high performance social application and store more than 8 billion objects and 400 terabytes of data in AWS Cloud using a service called Amazon Simple Storage Service, or in short Amazon S3. And not only that, they are running 225,000 instance hours a month, and they run that on Amazon compute service called Amazon EC2 or Amazon Elastic Compute Cloud. Spotify is another company that got benefited using AWS. It's an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify needed a peculiar requirement. It needed a storage solution that could scale very quickly without incurring long lead times for upgrades. Long story short, Spotify used Amazon S3, which is Amazon Simple Storage Service, and Amazon S3 gave them the confidence in their ability and to expand their storage quickly while also providing high data durability. The third biggest company I want to mention is Netflix. It's the world's largest internet television network with more than 100 million members in more than 190 countries. Netflix uses Amazon Web Services for nearly all its computing and storage needs. Now that includes database, analytics, recommendation engines, video transcoding, and a lot more. Not only that, this company is planning to use AWS Lambda to build an automated or an rule-based self-managing infrastructure and replace some of their inefficient process to reduce the rate of errors, and replace inefficient processes to reduce the rate of errors and save their valuable time. Expedia is another famous company that got benefited by using cloud. Expedia provides travel booking service through its flagship site called Expedia.com, and not only that, they also run 200 plus travel booking sites around the world. Expedia is all on AWS, and by using AWS, Expedia has become more resilient with an high scalable infrastructure and better cloud services because it had offloaded the IT management to the cloud provider itself, in this case AWS. And because of this, Expedia's developers have been able to innovate faster while saving the company millions and millions of dollars. As next thing, let's talk about the different cloud providers. Amazon Web Services, AWS, is a cloud computing service provided by Amazon. It provides a mix of infrastructure as a service, IaaS, platform as a service, PaaS, and packaged software as a service called SaaS offerings. Microsoft Azure, formerly known as Windows Azure, is a cloud computing service by Microsoft, and it sort of specializes in using cloud for building, testing, deploying, and managing the applications through the servers throughout a global network that Microsoft manages. It also provides software as a service, platform as a service, infrastructure as a service, and it supports lots of different programming languages and tools and frameworks, including both Microsoft and third-party software and systems. IBM Cloud is a cloud computing service offered by IBM. IBM Cloud includes infrastructure as a service, software as a service, platform as a service. Now, the difference is here it offers through public, private, and hybrid cloud delivery models. VMware, on the other hand, is an subsidiary of Dell Technologies and provides cloud computing and platform virtualization software and services. It was the first commercially successful company to virtualize the x86 architecture. Google Cloud Platform, on the other hand, is offered by Google. It's a suite of cloud computing services that run on the same infrastructure that Google uses internally for its end-user products such as the Google Search and the YouTube we are familiar with. Alongside a set of managed tools, it also provides cloud services including computing services, data storage services, data analytics, and machine learning services. DigitalOcean, on the other hand, is headquartered in New York City with data centers worldwide. DigitalOcean provides developers cloud services that help to deploy and scale applications that run simultaneously on multiple computers. As of January 2018, DigitalOcean was the third largest hosting company in the world in terms of web-facing computers. Let's talk about cloud computing in AWS. Amazon Web Services, AWS, is a cloud computing service provided by Amazon, and these services are accessible over the internet. And because AWS provides infrastructure as a service, it's a flagship offering, we can create and deploy any type of application in the cloud on top of the IaaS that Amazon provides. And you know, the best part here is the subscriptions are pay-as-you-go type. You use less and pay less, and only for what you have used. You use more, pay more, but still less per unit for the service used. Attractive, isn't it? Now let's talk about the life cycle of the cloud computing solution. The very first thing in the life cycle of a solution or a cloud solution is to get a proper understanding of the requirement. I didn't say get the requirement, but said get a proper understanding of the requirement. It is very vital because only then we will be able to properly pick the right service offered by the provider. Getting a sound understanding, the next thing would be to define the hardware. Meaning choose the compute service that will provide the right support where you can resize the compute capacity in the cloud to run application programs. Getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all. There are different services and hardwares for different needs you might have, like EC2 if you're looking for IaaS, and Lambda if you're looking for serverless computing, and ECS that provides containerized service. So there are a lot of hardwares available. Pick the right hardware that suits your requirement. The third thing is to define the storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud or from the internet. And choose the appropriate storage. There is one separately for backup called S3, and there is one separately for archival, that's for Glacier. So you knowing the difference between them really helps in picking the right service for the right kind of need. Define the network that securely delivers data, video, and applications. Define and identify the network services properly. For example, VPC for network, Route 53 for DNS, and direct connection for private P2P line from your office to the AWS data center. Set up the right security services, IAM for authentication and authorization, and KMS for data encryption at rest. So there are a variety of security products available. We got to pick the right one that suits our need. And there are a variety of deployment and automation and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, autoscaling is for being elastic, and CloudFormation is define the management process and tools. You can have complete control of your cloud environment if you define the management tools which monitors your AWS resources and or the custom applications running on AWS platform. There are a variety of deployment, automation, and monitoring tools you can pick from, like CloudWatch for monitoring, autoscaling for automation, and CloudFormation for deployment. So knowing them will help you in defining the lifecycle of the cloud computing solution properly. And similarly, there are a lot of tools for testing a process like CodeStar and CodeBuild and CodePipeline. These are tools with which you can build, test, and deploy your code quickly. And finally, once everything is said and done, pick the analytics service for analyzing and visualizing the data using the analytics services, where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Athena, and other tools for analytics are EMR, and which is Elastic MapReduce, and Cloud Search. Alright, enough of theory, and let's have a quick look at how two services in AWS, EC2 and S3, work together and benefits us. Here are two IT professionals talking to each other. One says, I have an application which takes a lot of storage and works only on Linux system, which I do not have at the moment. And the other one is a smart guy, and he immediately replies that he could use S3 to store data and retrieve data, and use EC2 for all his compute needs. And then the curious conversation builds up, and the first person wants to know what is EC2 and S3. And the second guy starts to explain that AWS EC2 is a web service that provides a secure and resizable compute capacity in their cloud. And EC2, it can also be used to launch as many virtual servers as we need. And about S3, he explains AWS S3 is a simple storage service provided by AWS. And about S3, he explains further, saying that using Amazon S3, we can store and retrieve any amount of data at any time on the web. Alright, so the very first thing is to have an AWS account. So create an AWS account. And second thing is to create an AWS S3 bucket and upload the files there. The files that EC2 server is going to pull from will get stored in S3 as first thing. Alright, so the first thing is to create an S3 bucket. So let's create an S3 bucket and let's call it as website bucket. And these names will have to be unique. So let's see if this bucket name is available. It says bucket name already taken or already exist. So let me top it up with SL, meaning Simplilearn. Alright, so we were able to create a bucket, and in that bucket let me upload a content. That basically is going to be my index file that's going to go and sit in my web server. So let me also make it public and view it. Alright, so this is the content that I have stored in my S3, and this is the content I'm going to push to my EC2 server. Right. Second step, create an AWS S3 bucket and upload files. We're done with that. Third is to create an EC2 instance. That's, in other words, create an virtual machine in the cloud. Let's go and create it. Alright, the third thing is to create an EC2 instance. So let's create an EC2 instance. It's plain and it's very simple. I'm going to keep everything as defaults here. Alright, so I've launched an EC2 instance. As you see, it's running. I also have an IP address, public IP address here. With that, I have logged into this EC2 instance, and I'm in the folder /var/www/html, and as you see, there is nothing in there at the moment. And this server also has Apache installed in it. As you can see, I browsed to the IP address of the EC2 instance and it's showing a page, which is the default Apache page. Alright, if I had any files in this folder, that would get shown as the web page instead of the default page. Our task is to save files in S3 and move them to the EC2 instance. So S3 is going to act as a storage or a repository or a source code control in this example. Alright, so let's do that. Alright, the third step is to create your EC2 instance, and that's what we have done. And the EC2 instance has no files in it. And the fourth step is to synchronize the source code bucket with the EC2 instance. Let's do that. The actual command to do that would be AWS S3 sync, and then the name of the bucket from which we're going to pull the code and the folder in which we're going to put the code or the data. Alright, so it has downloaded something. Look at that. And now if we go back to the test page and do a refresh, there you go. It's showing the page that it pulled from S3. So here I can use S3 as the source code control bucket, and any information that I put in there will get reflected in EC2 instance once I do a sync every day. And that's how I use S3 as my storage for EC2. Alright, finally we were able to synchronize S3 bucket and the EC2 instance. And we were also able to view the results in the web browser of the EC2 instance. The data was copied from S3 to the EC2 instance, and that we were able to view from the web browser.
AWS, Azure and GCP are three of the world's largest cloud service providers. But how are they different from each other? Let's find out. Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with Ec2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides Dynamodb, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
Today we're going to delve into Git and what it actually is and how it fits within your DevOps stack. So a little scenario before using Git. One of the challenges that a lot of developers and development teams would have had is developers would be working on different types of code, whether it was database code, whether it was Python, or whether it was Java or .NET, and they would have a central server that they would be pushing all of their source code in. But there was little or no communication that was actually going on in between all the developers. The challenge you had with that scenario is that when people would be checking in code, you could be like, there'd be conflicts and you'd have to roll back different code versions. And this is really kind of the challenge that Git addresses. Git is a tool that allows all of the developers, no matter what stack they're working in, to have access to all of the code. And it makes it much more effective at being able to have development teams work on small, medium, or even massive applications. And some of the biggest applications out there are managed through a Git distributed server environment. So let's jump into what we'll be covering so you have a clear understanding of the value that you're going to get out of watching this presentation. So we're going to go through DevOps and the tools we have available for DevOps. We'll talk about what version control means within a DevOps environment and cover the two different types of version control, centralized and distributed. And then we're going to zero in on Git, which is a really fantastic distributed version control system. And we're going to go through and understand the features, workflow, branches, and commands in Git. We're going to give you a demo and then summarize all of the activities at the end of the presentation. So, what is DevOps? Well, this is one of my favorite questions. I love the idea of what DevOps is. So DevOps really is a culture of being able to deliver solutions faster, where your development teams and your operation teams work effectively together. The idea is to be able to continuously build out solutions and have testing codes that's built into your solutions, so that no matter where they are in the stage of the integration and deployment lifecycle, they're always being tested and you can always have code getting ready to be released out. The idea is that instead of having big releases that you would have maybe once every 2 weeks or once a month, that you would actually have a continuous stream of releases, because you always have code that is being tested. You have your network that's being tested, you have your environment being tested, and you'll be able to provide feedback directly to the appropriate person, whether they're in devs or whether they're in ops, to be able to be successful at being able to deliver solutions faster. The bottom line, your dev team thinks like operations, and your operations team begin to think like developers. It's really a fantastic way of being able to speed up delivery and have your team just think and feel and act in a different cultural environment. So let's have a look at some of the tools that are available to you in DevOps environments. If we look at DevOps, it's really kind of split into two areas. The dev side, you have building, code, planning, and testing. And then on your ops side, you have release, deployment, operating, and monitoring. But the tools really all interact with each other. And what's really great is that the tools are either open source or very, very low in cost. And in fact, most of the tools that you're seeing in front of you right now are open source tools, which means there's no licensing to you, and you can actually effectively manage them and implement them within your team right now. So let's have a look at some of the dev tools that you have for doing code versioning. And so some of the tools that you may have used in the past include Subversion, Team Foundation Service, and Git. These are all different types of version control software that you have out there. One of the oldest ones is Subversion. It's a centralized version control system. It's one of the tools I used years ago. It really is good at doing what it's supposed to do, which is just a very simple version controlled solution. It's open source, so it's free. There's no licensing. There are challenges with working with it because it is a centralized tool rather than a distributed tool, and we'll get into that in a little bit. But for a very basic version control system, it does what you want it to do. Team Foundation Service Solutions is something that many of you in Microsoft world may have been using for a long time. And the thing that's great about TFS is that it's built right into the Microsoft environment. It's the server side, the services side of building out your solutions with Microsoft. Just recently, in the last couple of weeks, at the beginning of September 2018, Microsoft actually just rebranded TFS as Azure DevOps, and so you have Azure pipelines, and there are 5 now Azure tools that actually replace TFS. But these are all tools that are very similar in concept. The old TFS tools are very similar to the centralized SVN tools, whereas the new tools that are part of Azure are actually much more aligned with Git. So what you're seeing is Microsoft moving from the centralized server to a distributed server with their new Azure DevOps tools, which is fantastic news for every developer listening to this. And then we have Git, and Git is a distributed version control system. It is, again, open source, which means that you can start using it right now without fear of having to have any costs or any penalties. And the thing that's really good about it is that it's really, you can use it for almost any kind of digital project. And what it's good at is being able to create that historical record and versioning of your source code, whether you're doing a web application, a mobile application, or you're actually building a Python script for a machine learning solution. So let's dig into what version control systems are and how they can be of value to you. So the role of a version control system is to allow developers to be able to check in their files into a repository. And here you can actually see how we can check in 3 files into a repository, and that repository then becomes a snapshot or a historical record of the files that we're working on. And you want to be able to have it so that the repository is flexible enough so that as you want to be able to scale and add in new files or new versions of a file, that you can actually do that easily within your VCS environment. And the goal is to be able to constantly have each of these versions available so that anybody that wants to be able to check out the file can actually have the latest version or see a history of how that file became what it control systems, and then we'll compare it against distributed version control systems. So a centralized version control system has a central server where all the files are stored, and everybody has to check in and check out from that centralized server, and all of the versions are managed within that server environment. The problem is that if that central server crashes, which doesn't happen but very often, but it can happen, you end up losing all of your files. And I was actually on a project where that actually happened to us, and we lost 6 months of history of how the application was created. Fortunately for us, we actually had a backup, but it didn't have all the historical data. So we were able to at least continue working, but we just lost a lot of files and it took a while to get back into place. So let's now look at and compare this to a distributed version control system. With a distributed version control system, you still have a centralized server that manages the files. But the difference is that as a developer, you check out all of the files for a project. So you can actually manage the whole project locally on your development machine and make your changes. And then you can just check in and out the changes that you've made to the centralized server. The opportunity you have here is that the server itself, if it goes down, you're not going to be in a situation where you lose all of the history, because everybody that's working on the actual application has all of the versions of the code locally on their machine. Now, one of the more popular distributed version control systems that out there is Git. I mean, it really is probably the most popular by a margin compared to a system out there. So, let's dig into, what actually is Git. So Git is a version control system for managing files. And as a developer, you have a Git client on your machine, and you're able to make changes and create local repositories of a program on your computer. And then you can sync up with a remote service such as GitHub or GitLab or the new Azure Labs environment, where you can actually store files remotely and then allow remote teams to have access to those changes in the actual application you made. So you can track your changes easily. The tool is inherently distributed, so it makes it very easy to manage the code for large teams. And you can bring people in very quickly, and you can have people come in as specialists and spin them up quickly and have them work on a piece of the code and then drop them out of the project. If you want to have a check on how this works, go and start contributing to any of the many thousands of open source projects at GitHub, where you can go in with your Git tools and just contribute to those projects. And then finally, one of the things that I really like with Git is that it's not a linear development approach. It's not starting from A and going to Z. It's a non-linear approach, which allows you to have branches that people are working on in parallel to your master branch, where people are actually doing the delivery of the production code. So let's step through some of these features. So Git, as you can imagine, the first thing it does is track history. That's probably the most important part of having a version control system. It's free open source. You can actually go and use it right now. There are no costs for actually using it. It is a non-linear environment that allows people to be able to build out new features in parallel to the master branch, so that you can be constantly having the master code out there without and adding in new features without breaking the code. And you can automatically create backups because each developer has a version of the code remotely. It's incredibly scalable. Some of the biggest projects out there now are being managed through Git. And because of this scale, the collaboration becomes a byproduct of teams working together. And branching just is so much easier within Git. So as you can see, this whole thing leads to a very effective distributed environment. So let's step through some of the workflow that we have available for Git. So the way that Git works is that you, as an operator, as a developer, you have the Git client on your local development machine, whether it's a Linux machine, a Mac, or a PC, and you connect to a remote server and you pull down the latest working copy, and then you're able to make all of your changes locally, and you can modify the codes, you can review changes, and you can commit those codes to your Git repository that you have locally, and then you can push those changes back up to the remote server. And as soon as you push them into the remote server, those changes then become available to everybody else working on the project. So they can be constantly keeping everybody updated on all the work that is happening. So, typically the way that it would work is, you would start off with having the working file, the working directory that you have locally, and then you would stage those files into a staging area, and then you get those files ready to be committed to your Git repository. And these are all actions that you would do locally and then connect to a remote server. And then later, when you go back into work on your project, the first thing you should always do is check out that code, so that you always have the latest version of the code and everybody's kept in sync. So let's talk about branching in Git. So the way that branches work is that if you imagine you're working on a project, and projects always have a tendency of getting bigger than you imagine. And what you want to be able to do is keep that main product working and keeping it working effectively. But if you want to be able to add a feature to that product, you may have 2 or 3 different groups that are working on multiple features simultaneously. And what you want to be able to do is give them the freedom to work on those individual features. And the way you do it in Git is that you can create branches off the master, and while you're off the main branch, which is called the master. And so each person could be working on their own separate branch, and then when they want to, they can then later merge those branches back into the main master. And all this time, the main master still works and still able to produce the right code for the customer. But at the same time, it allows the developers the freedom to be able to write in their new features. And so we can look at this in a little bit more visually with the master branch. And we can put in small features and large features, and we can then merge them back as we need to. So this kind of covers some of the commands that we have in Git. So the first command you'd want to use is called Git Init, and that's allowing you to go into a folder on your local PC or your local Mac and convert that folder into a local Git repository, and that creates that repository. Then you want to be able to make changes to that repository, and the commands you'd be using in this instance would be add, commit, or status. You want to be able to sync your repositories with the remote server. So be able to put the code that you have on your computer on the remote server, you use push. You want to get the code from the remote server, you'd use pull and then add origin. And then if you want to do parallel development from the master branch, the main branch, you would use branch, merge, or rebase as ways to be able to do parallel development. And now we're going to go through and do a demo on Git. So we're going to do a demo on Git so you can feel comfortable running the commands in the interface and you're able to get Git running correctly in your environment. So the first thing we're going to do is we're going to set up which version of Git that you have, and then we're going to see if we can establish some global configurations within your Git environment. And we're going to do sandeep.dash as the name, the email address is sandeep.simplylearn, and then we're going to do a list of the different configuration settings we have. So to check the version of Git that we have, we do git -- version in our terminal or command line window. You can also use PowerShell. That'll actually get you running in the same environment as well. All of these tools are going to be command line tools. And then the next thing we're going to do is we're going to assign some global usernames and a global email address so that we can actually access the Git account itself locally on the device. And so we're going to put in config -- global user.name Sandeep, and then git config -- global user.email and sandeep.d@simplylearn.net. And now we're going to check the list of usernames and email IDs in our configuration environment with -list, and you'll see that we have everything in there correctly. Here is our username right here, and our name and our email ID. So if you need any help when you're actually doing any of your work in Git, all you have to do is do git help config or git config -- help, and this will allow you to actually get access to the help screens. So let's just go and type that in, git help config, return, and this takes us to the help page that's running locally on your device. And here we have a breakdown of all the different commands and what those commands actually do within a Git configuration. And we can go ahead and we can do git config -- help, and that will actually take us to the same page. So two ways of doing the same thing. So we're going to go ahead and we're going to create a test repository on our local system, and we're going to do that with make directory called test, and then we're going to move our cursor within command window, terminal window, to the test folder, and then we're going to initialize that folder to become a Git repository. So let's go ahead and do that. So we're going to make a new directory and we're going to call it test, and we're going to move the cursor so it's actually in the test folder. We do cd change directory to test, and you can see now we're actually in the test folder. And now what we have to do is initialize this folder as a Git repository. And so we're going to do this as Git Init, and it's now a new Git instance that we can actually now use for managing our Git environment. So we're going to create a new file and we're going to call it info.txt, and we're going to put some content in it, and we're actually going to put it in the folder that we've just created so you can actually see what it's like to test out the Git environment with a file that hasn't been checked into it yet. So let's go ahead and do that. So we open up our folder directory, and here you can see we have the test folder, and we're just going to go ahead and create a default test file. So right click, text, new document, info.txt, open that, and you can put really whatever you want in here. We're just going to put in this information right now, name equals Sam, registration number 12479, and save that file, close it out. Now if we actually go ahead and run a git status command, you'll see that the info.txt file is in red. That's because that file has not actually been checked into the project. It's a new file that we've added, but it hasn't been committed yet into the Git repository. So let's go ahead and see what it takes to actually add the file to the Git repository that we just created. So we're going to do that by doing git add info.txt, and then we're going to commit that into the history of that Git repository. So it now has version control, and we can start doing forking and other kind of similar activities when we connect later to our GitHub Git environment. So we do git add info.txt, and remember we're actually still in the test folder, so it's going to look for that file in that folder and just add it in. And now if we go ahead and do git status, we'll actually be able to see that the info.txt file is in an active color. First of all, we have to commit it, so we go git commit -m, and then we're going to commit, and we add in some quick text here. You can write whatever you want. Committing the text file is now actually committed into the Git repository, and it's still running locally on your PC. So we're going to go make some changes to the file, and we're going to save it, and we want to be able to see how we can use Git to compare the differences between the two files. So let's go over and we're going to make some changes to the info.txt file. Here we are, here's info.txt. We're just going to add in a new line. We're going to add in the line address, and we're going to save that file. And now when we go over to Git, we're going to be able to review the difference. So we're going to do git diff, And here you actually see that we've added in a new address file. So now you can actually see this is the difference between the two documents. Now, as you can imagine, when you have code, this would become more elaborate, where actually will show you code that's been pulled out if you've reduced eliminated any code, or if you added in new code. Really useful. So we're going to go ahead and add our Git username to a remote location so we can actually start testing out the file that we've created into a remote repository. In this case, we're going to use GitHub, and you'll be able to see how we can actually then save that file into a Git repository that somebody else could then access and be able to make edits to. So let's just go ahead and make those changes. So git config -global user.username, and we're going to do Simplilearn. And that will associate it with this Git repository that we've just created locally. So Simplilearn-GitHub. So Simplilearn GitHub is the username that we use on GitHub. So we're going to go over to GitHub. Here we are in GitHub, and then correct new repository. And then, as you can see, we're in Simplilearn-GitHub, and we're going to call the new repository test. We're going to make it public so anybody can access it. And you'll see that it automatically adds a README file. And we have our test environment set up correctly. So we'll go ahead and copy the URL link, which is github.com simplilearn-github/test.git. Copy that, and we'll go back over to our command line window. And so now we're going to add the username to the GitHub configuration. So what we're doing is we're connecting the local repository to the remote repository. So we type git remote add origin, and then we'll paste in the address. And this then allows us to connect the local repository that we created in the test folder with the remote repository. And now we're connected. So now that we've connected, we can actually push the file that we have in the local repository on your PC or Mac to the remote repository in the GitHub server environment. So let's go ahead and do that. So we're going to do git push, and push is the command to push the documents from the origin, which is the local file, to master, and master is a remote file. Hey, and there we are. Success. So what we have now is the file that we just created in our local Git repository is actually now in the remote repository as well, so anybody can access it. So let's go have a look at that. So we're going to refresh the GitHub page, and hey, there we are. There's info.txt has been uploaded, and we're ready to go. That's great. That's what you should be seeing. So refreshing your web page on the remote GitHub folder, and it could be any Git service, but we just happen to be using GitHub because it's free to use. You'll be able to see that the local file has been installed and is now part of the Git repository in the remote server. So what we're going to do now is we're going to create 3 more files, and we're just going to call them info.txt, info2, and info3. And then we're going to push them out to the remote server, and we're going to merge everything together into a single environment. So let's go ahead and create those 3 files, and we're just going to add those into the folder. So let's go ahead, create new text document, info1, and then we're going to create info2, and then info3. I'll get my typing right here. Okay, here we go. There we are. Okay, I'm opening info3, and I'm just going to enter some text in here. And what we're going to do is illustrate how we can do branching. And each of these files I'm going to save and then close out. And now I can go over and... So let's create a new branch. And we're going to call this one first_branch. And we go git branch first_branch, and this will be a new branch of the code environment that we're creating. And so hit return, and that allows us to create a new branch. And so what we do is we're going to move to the new branch. So we're going to do git checkout first_branch, and that allows us to move into that branch. And you'll see that info.txt is already there, which is good. That's what we want to see. Now what we need to do is add in the new documents. So here we have the different steps we've taken. We created a branch, we moved to the new branch, and now we're going to go ahead and add the info3 txt to that branch so you can actually see everything coming together. And we're going to go with git add info3.txt. So we're just adding a file like we were previously with our first initial Git folder, and that file has now been added to the first branch. So we're going to go ahead and commit the file to the first branch, and then we're going to merge the documents into the master branch so we have everything together. So let's go ahead and do those steps. We're going to do the commit first, and then we're going to merge everything together. All right, so we do git commit -m, and we'll just put in, we're just going to say made changes to first branch, and that's just documentation so that we know what we've done. And there we are, we've committed the file. So we had that file info3 txt committed, and now we're going to go ahead and merge the files into the main master, and so we can actually have everything together as one consistent environment. And we do that by typing in, so this lists out what we have in our master file. So we just do ls, and that shows everything in the folder, and we have info.txt, info1.txt, info2.txt, and info3.txt are now all in the first branch. So let's go ahead and we're going to merge. Okay, so actually before we merge, we have to check out the master branch. So we do git checkout master, so it gets us into the master branch, and you'll see that we have just one file there, info.txt. So we're going to list out the files in the master branch, and so what you'll see is info.txt, info1 text, and info2 text are there, but info3 text isn't there because that was created in a separate branch. So let's go ahead and merge the first branch into the master branch. So we do git merge, and we do first underscore branch, and there we are, we've merged it in, and excellent, that looks good. So let's go ahead and list out the files that we have in the master branch, and we do ls, and then you'll see that we have 4 files, including the info3.txt that we had in a separate branch, now all in the master branch.
Welcome to Git Commands. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git Bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git Bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git Bash. But what does it take for you to share this repository with another user who has also got Git Bash installed on his system? This is where you would need something called as a Git server. So for user 1 or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free, some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with 2 variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products, and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very, very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition, which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user 2, the first thing that I got to do is have an access to a Git server where both user 1 and user 2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user 2 or the other developer who wishes to collaborate with me on this repository can use his credentials as long as he's registered properly on the Git server. He can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. All right, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use Git from Windows command prompt. That sounds good for me. Open SSH. That's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch Git bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. All right, a lot of Git help commands. Everything looks good. So I ended up installing the Git bash. I can go ahead with all other commands. Now that I have Git bash installed on my system, let me open up a Git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git bash to be configured with. The command to do that is git config --global, which means that this setting that I'm going to set would be a global setting. User.name, and the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config --global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete that in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder. And this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that, because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the Create Repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master. Link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I will click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with the README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random README file with some content in it gets created and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. Ask me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial when I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 files, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local. None of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes, because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit, and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3 and possibly C4. Alright, so this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3. Better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead from C5. I see another commit, but what was there as a part of this commit actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is Git demo, and then I'm going to create a new folder here. I'll create a folder called org details. All right, this is my folder here. All right, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. All right. So if at all I do a git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only one commit and there are two files here. You can see those two files that is here. All right. So at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly two files the way it was earlier. Because I've created a branch from my base branch, which is the master branch. And when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. All right. So let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn, Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. and I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server, and let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch? Master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in two branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these two branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git checkout, the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch, and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
In this session, we're going to deep dive into what Jenkins is and how it improves your DevOps continuous integration environments. So let's talk a little bit about life before Jenkins. Let's see this scenario. I think it's something that maybe all of you can relate to. As developers, we all write code and we all submit that code into a code repository, and we all keep working away, writing our unit tests, and hopefully we're running our unit tests. But the problem is that the actual commits that actually get sent to the code repository aren't consistent. You as a developer may be based in India, you may have another developer that's based in the Philippines, and you may have another team lead that's based in the UK, and another development team that's based in North America. So you're all working at different times, and you have different amounts of code going into the code repository. There's issues with the integration, and you're kind of running into a situation that we like to call development hell, where things just aren't working out and there's just lots of delays being added into the project, and the bugs just keep mounting up. The bottom line is the project is delayed. And in the past, what we would have to do is we'd have to wait until the entire software code was built and tested before we could even begin checking for errors. And this just really kind of increased the amount of problems that you'd have in your project. The actual process of delivering software was slow. There was no way that you could actually iterate on your software, and you just ended up with just a big headache with teams pointing fingers at each other and blaming each other. So let's jump into Jenkins and see what Jenkins is and how it can address these problems. So Jenkins is a product that comes out of the concept of continuous integration that you may have heard of as power developers, where you'd have two developers sitting next to each other coding against the same piece of information. What they were able to do is to continuously develop their code and test their code and move on to new sections of code. Jenkins is a product that allows you to expand on that capacity to your entire team. So you're able to submit your codes consistently into a source code environment. So there are two ways in which you can do continuous delivery. One is through nightly builds and one is through continuous. So the approach that you can look at continuous delivery is modifying the legacy approach to building out solutions. So what we used to do is we would wait for nightly builds, and the way that our nightly builds would work and operate is that as code developers, we would all run and have a cutoff time at the end of the day that was consistent around the world, that we would put our codes into a single repository. And at night, all of that code would be run and operated and tested to see if there were any changes, and a new build would be created. And that would be referred to as the nightly build. With continuous integration, we're able to go one step further. We're able to not only commit our changes into our source code, but we can actually do this continuously. There's no need to race and have a team get all of their code in at an arbitrary time. You can actually do a continuous release, because what you're doing is you're putting your tests and your verification services into the build environment. So you're always running cycles to test against your code. This is the power that Jenkins provides in continuous integration. So let's dig deeper into continuous integration. So the concept of continuous integration is that as a developer, you're able to pull from a repository the code that you're working on, and then you'll be able to then at any time submit the code that you're working on into a continuous integration server. And the goal of that continuous integration server is that it actually goes ahead and validates and passes any tests that a tester may have created. Now, if on the continuous integration server a test isn't passed, then that code gets sent back to the developer, And the developer can then make their changes. It allows the developer to actually do a couple of things. It allows the developer not to break the build, and we all don't want to break the builds that are being created, but it also allows the developer not to actually have to run all of the tests locally on their computer. Running tests, particularly if you have a large number of tests, can take up a lot of time. So if you can push that service off to another environment, like a continuous integration server, it really improves the productivity of your developer. What's also good is that if there are any code errors that have come up that may be beyond just the standard CI test, so maybe there's a code, the way that you write your code isn't consistent, those errors can then be passed on easily from the tester back to the developer too. The goal from doing all of this testing is that you're able to release and deploy, and your customer is able to get new code faster, and when they get that code, it simply just works. So let's talk a little bit about some of the tools that you may have in your continuous integration environment. So the cool thing with working with continuous integration tools is that they are all open source, or at least the ones that we have listed here are all open source. There are some that are private, but typically you'll get started with open source tools, and it gives you the opportunity to understand how you can accelerate your environment quickly. So Bamboo is a continuous integration tool that specifically runs multiple builds in parallel for faster compilation. So if you have multiple versions of your software that runs on multiple platforms, this is a tool that really allows you to get that up and running super fast so that your teams can actually test how those different builds would work for different environments. And this has integration with Ant and Maven and other similar tools. So one of the tools you're going to need is a tool that allows you to automate the software build, test, and release process. And BuildBot is that open source product for you. Again, it's an open source tool, so there's no license associated with this. So you can actually go in and you can actually get the environment up and running, and you can then test for and build your environment and create your releases very quickly. So BuildBot's also written in Python, and it does support parallel execution jobs across multiple platforms. If you're working specifically on Java projects that need to be built and tested, then Apache Gump is the tool for you. It makes all of those projects really easy. It makes all the Java projects easier for you to be able to test with API level and functionality level testing. So one of the popular places to actually store code and create versioning of your code is GitHub, and it's a service that's available on the web, just recently acquired by Microsoft. If you are storing your projects in GitHub, then you'll be able to use Travis Continuous Integration, or Travis CI, and it's a tool designed specifically for hosted GitHub projects. And so finally, we're covering Jenkins, and Jenkins is a central tool for automation for all of your projects. Now, when you're working with Jenkins, sometimes you'll find that there's documentation that refers to a product called Hudson. Hudson is actually the original version of the product that finally became Jenkins, and it was acquired by Oracle. When that acquisition happened, the team behind Hudson was a little concerned about the direction that Oracle may potentially go with Hudson, and so they created a hard fork of Hudson that they renamed Jenkins, and Jenkins has now become that open source project. It is one of the most popular and continuously contributed projects that's available as open source, so you're always getting new features being added to it. It's a tool that really becomes the center for your CI environment. So let's jump into some of those really great features that are available in Jenkins. So Jenkins itself is really comprised of 5 key areas around easy installation, easy configuration, plugins, extensibility, and distribution. So as I mentioned, for the easy installation, Jenkins is a self-contained Java program, and that allows it to run on most popular operating systems, including Windows, Mac OS, and Unix. You can even run it on Linux. It really isn't too bad to set up. It used to be much harder than it is today. The setup process has really improved. The web interface makes it really easy for you to check for any errors. In addition, you have great built-in help. One of the things that makes tools like Jenkins really powerful for developers and continuous integration teams and your DevOps teams as a whole, when you have plugins that you can then add in to extend the base functionality of the product. Jenkins has hundreds of plugins, and you can go and visit the update center and see which other plugins that would be good for your DevOps environment. Certainly check it out. There's just lots of stuff out there. In addition to the plugin architecture, Jenkins is also extremely extensible. The opportunity for you to be able to configure Jenkins to fit in your environment is almost endless. Now, it's really important to remember that you are extending Jenkins, not creating a custom version of Jenkins. And that's a great differentiation because the core foundation remains as the core Jenkins product. The extensibility can then be continued with newer releases of Jenkins. So you're always having the latest version of Jenkins and your extensions mature with those core foundation. The distribution and the nature of Jenkins makes it really easy for you to be able to have it available across your entire network. It really will become the center of your CI environment, and it's certainly one of the easier tools and more effective tools for DevOps. So let's jump into the standard Jenkins pipeline. So when you're doing development, you start off and you're coding away on your computer. The first thing you have to do when you're working in the Jenkins pipeline is to actually commit your code. Now, as a developer, this is something that you're already doing, or at least you should be doing. You're committing your code to a Git server or to an SVN server or a similar type of service. So in this instance, you'll be using Jenkins as the place for you to commit your code. Jenkins will then create a build of your code, and part of that build process is actually going through and running through tests. And again, as a developer, you're already comfortable with running unit tests and writing those tests to validate your code. But there may be additional tests that Jenkins is running. So for instance, as a team, you may have a standard set of tests for how you actually write out your code so that each team member can understand the code that's been written. And those tests can also be included in the testing process within the Jenkins environment. Assuming everything passes the tests, you can then get everything placed in a stage and release ready environment within Jenkins. And finally, you're getting ready to deploy or deliver your code to a production environment. Jenkins is going to be the tool that helps you with your server environment to be able to deploy your code to the production environment. And the result is that you're able to move from a developer to production code really quickly. This whole process can be automated. Rather than having to wait for people to actually test your codes or going through a nightly build, you're looking at being able to commit your code and go through this testing process and release process continuously. As an example, companies Etsy will release up to 50 different versions of their website every single day. So let's talk about the architecture within Jenkins that allows you to be so effective at applying a continuous delivery DevOps environment. So the server architecture really is broken up into two sections. So on the left-hand side of the section, you have the code the developers are doing and submitting that code to a source code repository. And then from then, Jenkins is your continuous integration server. And it will then pull any code that's being sent to the source code repository and will run tests against it. It will use a build service such as Maven to actually then build the code. And at every single stage that we have that Jenkins manages, there are constant tests. So for instance, if a build fails, that feedback is sent right back to the developers so that they can then change their code so that the build environment can run effectively. The final stage is to actually execute specific test scripts. And these test scripts can be written in Selenium. So it's probably good to mention here that both Maven and Selenium are plugins that run in the Jenkins environment. So before we were talking about how Jenkins can be extended with plugins, Maven and Selenium are just two very popular examples of how you can extend the Jenkins environment. The goal to go through this whole process, again, it's an automated process, is to get your code from the developer to the production server as quickly as possible, have it fully tested, and have no errors. So it's probably important at this point to mention one piece of information around the Jenkins environment, that if you have different code builds that need to be managed and distributed, this will require that you need to have multiple builds being managed. Jenkins itself doesn't allow for multiple files and builds to be executed on a single server. You need to have a multiple server environment with running different versions of Jenkins for that to be able to happen. So let's talk a little bit about the master-slave architecture within Jenkins. So what we have here is an overview of the master-slave architecture within Jenkins. On the left-hand side is the remote source code repository, and that remote source code repository could be GitHub, or it could be Team Foundation Services, or the new Azure DevOps code repository, or it could be your own Git repository. The Jenkins server acts as the master environment on the left-hand side, and that master environment can then push out to multiple other Jenkins slave environments to distribute the workload. So it allows you to run multiple builds and tests and production environments simultaneously across your entire architecture. So Jenkins slaves can be running the different build versions of the code for different operating systems, and the server master is controlling how each of those builds operate. So let's step into a quick story of a company that has used Jenkins very successfully. So here's a use case scenario. Over the last 10 or 15 years, there has been a significant shift within the automotive industry where manufacturers have shifted from creating complex hardware to actually creating software. We've seen that with companies such as Tesla, where they are creating software to manage their cars. We see the same thing with companies such as General Motors with their OnStar program. And Ford just recently have rebranded themselves as a technology company rather than just an automotive company. What this means, though, is that the software within these cars is becoming more complex and requires more testing to allow more capabilities and enhancements to be added to the core software. So Bosch is a company that specifically ran into this problem, and their challenge was that they wanted to be able to streamline the increasingly complex automotive software by adopting continuous integration and continuous delivery best practices, with the goal of being able to delight and exceed the customer expectations of the end user. So Bosch has actually used CloudBees, which is the enterprise Jenkins environment. So to be able to reduce the number of manual steps such as building, deploying, and testing, Bosch has introduced the use of CloudBees from Jenkins, and this is part of the enterprise Jenkins platform. It has significantly helped improve the efficiencies throughout the whole software development cycle, from automation, stability, and transparency, because Jenkins becomes a self-auditing environment. Now, the results have been tangible. Previously, it took 3 days before a build process could be done, and now it's taken that same 3-day process and reduced it to less than 3 hours. That is significant. Large-scale deployments are now kept on track and have expert support, and there is clear visibility and transparency across the whole operations through using the Jenkins tools.
Let's get started with Jenkins. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command, opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain two servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. All right, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. All right, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using these environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system, but in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, all right, so I've just set in a Java home variable. If you see this, C: program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. All right. So what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right, so this is my downloaded Jenkins instance, or rather installer. This is a pretty, maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C:\program files 86 and Jenkins folder. If at all you run a war file, depending upon the user ID with which you're running a war file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right, so this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C:\program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right, so there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a war file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it'll crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors, 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right. So no other configurations that I'm going to change here. All of these look good. All right. So I come back to Manage Jenkins. Okay. One other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins' own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have a some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item. Little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I've not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, If I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right, so one job, one quick run, that's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins, which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I mean, I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to Manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That's good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I will say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer1 sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very simple repository that is there called Hello Java, and this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good, but what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right. If at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here you would see a red message saying that, something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository. And it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello. And there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As you would know, Maven is a very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a WAR file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need two other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide this user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using this credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now This is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job MVN web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credential that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this and let me first run this and see if it connects well, if there's any problem with my war file or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I will go to manage plugins, available, type in container, container, deploy to container. Okay, so this would be the plugin that I would need. I would install it without a restart. Okay, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So ****star.war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MVN web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the WAR file that is found in this particular folder, and then context path is mn web app. Use the deployer deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the WAR file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was mvn web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 8081. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the WAR file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he will do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave, but since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP, Java Network Launch Protocol. So using this, I would ensure that the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes. Agents, and by default this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol, and I'll configure the master and server to talk to each other using JNLP. So for that I need to enable this guy. So I enable this guy instead of making by default the configuration was disabled. So I make him random, I make him enabled, and I say save this configuration. Alright, so now I configured or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to your Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I just give an identifier saying that Windows node. I would say this is a permanent agent. I would say okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I'll keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C:program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that. And I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we got to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar agent server. In case the server and client are on different locations or different IPs, you have to specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials of the slave.jar along with the launch code and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be Or one dirty way to do that would be just, take a complete backup of our C program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my manage plugins. So this plugin is there. So hang on, backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to backup some data, and I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps, and all the files that is required as a part of it is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of backup, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all our workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or say hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
In this, we are going to talk about the Maven here. Now we will be talking about that how exactly we can make use of Maven here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use Maven here. Now Maven is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on, and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily to daily activities. Right now, Maven also helps us in getting the specific jar files for each and every project. So if you are going, you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your Maven there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it, the dependencies of each and every third-party binaries on the mvnrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvinrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right. So now what exactly is a Maven all about? So let's see on that part. So Maven is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish and deploy several projects at once. Maven is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the Maven here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. Right. Now Maven is a kind of a POM based project, so it also known as a project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now what exactly is a Maven repository all about? So Maven repository is something which is a kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three types of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository and then it will be utilized. So if you feel that the dependency is something which is not there in the local, it will be first downloaded from the remote repository and then it will be utilized or will be referenced onto the local machine there. And central repository is refers to the Maven community repository there, where you will be able to see each and every dependency present on that repository. So Maven downloads the repositories from here in the local repository whenever they're needed or whenever required. All these dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right now, what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning. Versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which searches for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step. Otherwise, it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right. Now, second thing is the dependencies and repositories. So dependencies usually refers to the Java files, so the Java libraries which we need into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download or we have to actually refer. And once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executive will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default, so it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site, so it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. Right, and Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package, and depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that, the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like mvn. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called mvn archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So mvn archetype generate. Now once we run that, so what will happen that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project, like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com.Simplilearn. So that's a value which I'm providing here. Artifact ID, I can make it like a sample project or something like that. I can do, so that will be the artifact ID which is there. So version I'm keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes, like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement, and this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if you run like mvn clean install, so it will be considered as a particular Maven project. A pom.xml file is already there present in the local directory. So according to that, the execution of the steps will be performed, and according to that you will be able to get some desired values here. So ultimately in the target directory you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending on your understanding, you can keep on adding or you can keep on modifying the dependencies, and that's how you can get the final result there. So that's it for this demo in which we have find out that how exactly we can go for a particular project preparation with the help of mvn executable. So that's it for this demo things, right? So that was the demo in which we saw that how exactly we can go for the Maven, and we can execute some build process related to Maven there.
Are you exploring test automation? Are you wondering why everyone is talking about Selenium around you? Do you want to know what Selenium is all about? If yes, this is the video for you. Alright, so let's get started. Manual testing. A definition, if you can say, a manual testing involves the physical execution of test cases against various applications, and to do what? To detect bugs and errors in your product. It is one of the primitive methods of testing a software. This was the only method which we knew of earlier. It is execution of test cases without using any automation tools. It does not require the knowledge of a testing tool, obviously, because everything is done manually. Also, you can practically test any application since you are doing a manual testing. So let's take an example. So say we have a use case. You are testing, say, a Facebook application. And in Facebook application, let's open the Facebook application and say create an account. This is your web page which is under test now. Now as a tester, what would you do? You would write multiple test cases to test each of the functionalities on this page. You will use multiple data sets to test each of these fields, like the first name, the surname, mobile number, or the new password. And you will also test multiple links. What are the different links on this page? Like say forgotten account or create a new page.
So these are the multiple links available on the web pages. Also, you look at each and every element of the web page, like your radio buttons, like your drop down list. Apart from this, you would do an accessibility testing. You would do a performance testing for this page, or say a response time after you say click on the login button. Literally, you can do any type of tests manually. Once you have these test cases ready, what do? You start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases one by one again until all the bugs are fixed and your application is ready to ship. Now, if one has to run test cases with hundreds of transactions or the data sets and repeat them, can you imagine the amount of effort required in that? Now that brings us to the first demerit of the manual testing. Manual testing is a very time consuming process and it is very boring. Also, it is very highly error prone. Why? Because it is done manually and human mistakes are bound to happen. Since it's a manual execution, testers' presence is required all the time. One needs to keep doing manual steps, step by step again all the time. He also has to create manual reports, group them, format them so that we get good looking reports. Also send these reports manually to all stakeholders. Then collection of logs from various machines where you have run your test, consolidating all of them, creating repositories and maintaining them. And again, since it's all is a manual process, there is a high chance of creating manual errors there. Scope of manual testing is limited. For example, let's say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them. And hence, you will pick and choose your test cases to execute. That way, you're limiting the scope of testing. Also, working with large amount of data manually is impractical, which could be the need of your application. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on application under test, and hence manually performing these kind of tests is not feasible. And to top it all up, say if you're working in an agile model where code is being churned out by developers, testers are building their test and they're executing them as and when the builds are available for testing. And this happens iteratively. And hence, you will need to run this test multiple times during your development cycle, and doing this manually definitely becomes very tedious and boring. And is this the effective way of doing it? Not at all. So what do? We automate it. So this tells us why we automate. 1, for faster execution. 2, to be less error prone. And 3, the main reason is to help frequent execution of our test. So there are many tools available in the market today for automation. One such tool is Selenium. Birth of Selenium. Much before Selenium, there were various tools in the market, like say RFT and QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks and he was working on a web application which needed frequent testing. He realized the inefficiency in manually testing this web application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and he named it as JavaScript Test Runner. Later, he made this open source and this was renamed as the Selenium Core. And this is how Selenium came into existence. And since then, Selenium has become one of the most powerful tools for testing web applications. So how does Selenium help? So we saw all the demerits of manual testing. So we can say by automation of test cases, 1, Selenium helps in speedy execution of test cases. Since manual execution is avoided, the results are more accurate, no human errors. Since your test cases are automated, human resources required to execute automated test cases is far less than manual testing. Because of that, there is a lesser investment in human resources. It saves time, and time is money. It's cost effective as Selenium is an open source. It is available free of cost. Early time to market. Since you save effort and time on manual execution, your clients will be merrier as you would be able to ship your product pretty fast. Lastly, since your test cases are automated, you can rerun them any point of time and as many times as required. So if this tool offers so many benefits, we definitely want to know more detail about what Selenium is. Selenium enables us to test web applications on all kinds of browsers like Internet Explorer, Chrome, Firefox, Safari, Edge, Opera, and even the headless browser. Selenium is an open source and it is platform independent. The biggest reason why people are preferring this tool is because it is free of cost. and the QTP and the RFT which we talked about are chargeable. Selenium is a set of tools and libraries to facilitate the automation of web application. As I said, it is not a single tool. It has multiple components which we'll be seeing in detail in some time. And all these tools together help us test the web application. You can run Selenium scripts on any platform. It is platform independent. Why? Because it is primarily developed in JavaScript. It's very common for manual testers not to have in-depth programming knowledge. So Selenium has this record and replay back tool called the Selenium ID, which can be used to create a set of actions as a script, and you can replay the script back. However, this is mainly used for demo purposes only, because Selenium is such a powerful tool that you should be able to take full advantage of all its features. Selenium provides support for different programming languages like Java, Python, C#, Ruby. So you can write your test scripts in any language you like. One need not know in-depth or advanced knowledge of these languages. Also, Selenium supports different operating systems. It has support for Windows, Macs, Linux, even Ubuntu as well. So you can run your Selenium test on any platform of your choice. And hence, Selenium is the most popular and widely used automation tools for automating your web applications. Selenium set of tools. So let's go a little more deeper into Selenium. As I said, Selenium is not a single tool. It is a suite of tools. So let's look at some of the major components or the tools in Selenium and what they have to offer. So Selenium has 4 major components. 1. Selenium ID. It's the most simplest tool in the suite of Selenium. It is integrated development environment. Earlier, Selenium ID was available only as a Firefox plugin, and it offered a simple record and playback functionality. It is a very simple to use tool, but it's mainly used for prototyping and not used for creating automation in the real-time projects because it has its own limitations like any other record and replay tool. Selenium RC. This is nothing but Selenium Remote Control. It is used to write web application tests in different programming language. What it does, it basically interacts with the browser with the help of something called as RC server. And how it interacts is it uses a simple HTTP POST GET request for communication. This was also called as Selenium 1.0 version, but it got deprecated in Selenium 2.0 version and was completely removed in 3.0, and it was replaced by WebDriver. And we will see in detail as why this happened. Selenium WebDriver. This is the most important component in the Selenium suite. It is a programming interface to create and execute test cases. It is obviously the successor of the Selenium RC which we talked about because of certain drawbacks which RC had. So what WebDriver does is it interacts with the browsers directly, unlike RC where the RC required a server to interact with the browser. And the last component is the Selenium Grid. So Selenium Grid is used to run multiple test scripts on multiple machines at the same time. So it helps you in achieving parallel execution. Since the Selenium WebDriver you can only do sequential execution, Grid is what comes into picture where you can do your parallel execution. And why is parallel execution important? Because in real-time environment, you always have the need to run test cases in a distributed environment. And that is what Grid helps you to achieve. So all this together helps us to create robust web application test automation. And we will go in detail about each of these components. So before that, let's look at the history of Selenium version. So what did Selenium version comprised of? It had an IDE, RC and Grid. And as I said earlier, there were some disadvantages of using RC. So RC was on its path of deprecation and WebDriver was taking its birth. So if you look at Selenium 2 version, it had an earlier version of WebDriver and also the RC. So they coexisted. From 3.0 onwards, RC was completely removed and WebDriver took its place. There is also a 4.0 version around the corner and it has more features and enhancements. Some of the features which are talked about are W3C WebDriver standardization, improved IDE and improved Grid. Now let's look at each of the components in the Selenium suite. Selenium IDE is the most simplest tool in the suite of Selenium. It is nothing but an integrated development environment for creating your automation scripts. It has a record and playback functionality and is a very simple and easy to use tool. It is available as a Firefox plugin and a Chrome extension. So you can use either of this browser to record your test scripts. It's a very simple user interface using which you can create your scripts that interact with your browser. The commands created in the scripts are called Selenice commands, and they can be exported to the supported programming language, and hence this code can be reused. However, this is mainly used for prototyping and not used for creating automation for your real-time projects. Why? Because of its own limitation, which any other record and replay tool has. So a bit history of Selenium IDE. So earlier, Selenium IDE was only a Firefox extension. So we saw that IDE was available since the Selenium version 1. Selenium IDE died with the Firefox version 55. That was, IDE was stopped supporting from 55 version onwards. And this was around 2017 timeframe. However, very recently, all new brand Selenium IDE has been launched by Apply Tools. And also they have made it a cross-browser. So you can install the extension on Chrome as well as an add-on on Firefox browser. So they completely revamped this IDE code, and now they have made it available on the GitHub under the Apache 2.0 license. And for the demos today, we'll be looking at the new IDE. Now with this new IDE also comes a good amount of features. Reusability of test cases, better debugger, and most importantly, it supports parallel test case execution. So they have introduced a utility called Selenium Side Runner that allows you to run your test cases on any browser. So you can create your automation using IDE, say on Chrome or Firefox, but through command prompt, using your side runner, you can execute these test cases on any browser, thus by achieving your cross-browser testing. Control flow statement. So initially in the previous versions of IDE, there were control flow statements available. However, one had to install a plugin to use them. But now it is made available out of box. And what are these control flow statements? These are nothing but your if-else conditions, the while loops, the switch case, and so on. It also has an improved locator functionality. That means it provides a failover mechanism for locating elements on your web page. So let's look at how this IDE looks and how do we install it and start working on that. So for that, let me take you to my browser. So say, let's go to the Firefox browser. So on this browser, I already have the IDE installed. So when you already have an IDE installed, you will see an icon here which says Selenium IDE. And how do you install this? You simply need to go to your Firefox add-ons. Here, where it says find more extension, so just type in Selenium IDE and search for this extension. So in the search results, you see this Selenium IDE. Just click on that. And now since I've already installed, here it says remove. Otherwise, for you, it is going to give you an add button here. Just click on the add button. It will install this extension. Once it is installed, you should be able to see this Selenium IDE icon here. Okay, so now let's go ahead and launch this IDE. So when I click on that, it is going to show me a welcome page where it's going to give me a few options. The first option is it says record a new test case in a new project. So straight away, if you choose this option, you can start recording a test case. In which case, it's going to just create a default project for you, which you can save it later. Then open an existing project. So you can open if you already have a saved project. Create a new project and close. So I already have an existing project with me for the demo purpose. So I'll go ahead and open that. So I'll say open existing project, and I have created a simple script. What the script does is it logs me into the Facebook using a dummy username and password. That's all. It's a very simple script with few lines, and this is what it's going to do. So what we will simply do is we'll just run the script and see how it works. For that, I'm just going to reduce the test execution speed so that you should be able to see every step of execution here. Alright, so what I'll do now here is I'll just adjust this window and I'll just simply say run current test. Alright, so I'll just get this side by side so that you should be able to see what exactly the script is doing. Okay, so now you're able to see both the windows. Okay, so now it's going to type in your user email here. There you go. And now it will enter the password and it has clicked on the login button. So it's going to take a while to say login, and since these are the dummy IDs, you are not able to log in here and you're going to see this error window. Fine, that is what is the expected output here. Now on the ID, if you look here, after I execute the test case, every statement or every command which I have used here is color coded in green. So that means this particular step was executed successfully. And then here in the log window, it will give you a complete log of this test case, right from the first step till the end. And your end result is, it says FB login, which is my test case name, completed successfully. Let's look at few components of this IDE. The first one is the menu bar. So let's go to our IDE. Alright, so So the menu bar is right here on the top. So here is your project name. So either you can add a new project here or rename your project. So since we already have this project which is named as Facebook. And then on the right, you have options to create a new project, open an existing project, or save the current project. And then comes our toolbar. So using the options in this toolbar, you can control the execution of your test cases. So first one here is the recording button. So this is what you use when you start recording your script. And then on the left, you have two options here to run your test cases. The first one is run all tests. So in case you have multiple test cases written here, you can execute them one by one sequentially by using this run all test. Else what you can do is if you just want to run your current test, this is what you would use. Then IDE has this debugger option which you can use to do a step execution. So say for example, now whenever I run the scripts, it's going to execute each and every command here sequentially. So instead, if I just select the first command and say do step execution, alright, so what it does is the moment it finishes the first command, which is opening of Facebook, right, I think which is already done here, yeah, alright, so once this is done, it is going to wait immediately on the second command and it says pause debugger. So from here, you can do whatever you would like to do. In case you want to change the command here, you can do that. You can pause your execution, you can resume your execution here, right? You can even completely stop your test execution, or you can just select this to run the rest of the test case. So if we say run the test case, what it is going to do is it's just going to simply go ahead and complete the test case. Now, there is another option here, which is, you see the timer there, which says test execution speed. So to execute your test cases in the speed you want. Say whenever you're developing an automation script, right, and say you want to give a demo. So you need to control the speed sometimes so that the viewer is able to exactly see all the steps which is being performed. And this gives you an option to control that complete execution, right? So do you see the grading here? So we have somewhere from fast to completely slow execution. So the previous demo which I showed was I controlled the speed and then I executed it so that we could see every command how it is being executed. Alright, so what's the next? This is called as an address bar. So whenever you enter an URL here, that is where you want to conduct your test. And another thing what it does is it keeps a history of all the URLs which you have used for running your test. Then here is where your script is recorded. So each and every instruction is displayed here in the order in which you have recorded the script. And then if you look here, you have something called as log and reference. So now log is an area where it records each and every step of your command as and when they get executed. Right? So if you see here, it says open https facebook.com and OK. So that means this command was executed successfully. And after the complete test case is done, it gives you whether the test case passed or failed. So in case there is a failure, you'll immediately see this test case is failed in red color. Also, there is something called as reference here. For example, say if I click on any of this command, the reference tab, what it is going to show me is details of this command which I have used in the script. It gives you the details of the command as well as what the arguments have been used or how is that you need to be using this particular command. Okay, so now what we'll do is let's go ahead and write a simple script using this IDE. So with this you'll get an idea as how do we actually record scripts in IDE. So for that I have a use case here, a very simple use case. So what we will do is we will open amazon.in, then we'll simply search for say product iPhone. And once we get that search page where all your iPhones are displayed, we will just do an assert on the title of the page. Simple. Alright, so let's do that. So first thing what I need is an URL. Okay, so first let me go to my Firefox browser here and say amazon.in. So why I'm doing this? Just to simply get the right URL, absolute URL path here. And so that I don't make any mistakes while typing in the URL. Okay, so I got this. So let me close all these windows. I don't need any of this. Let's minimize this. Alright, so here what I'll do, in the tests tab, I'll say add a new test and name this test as Amazon search. Done. I'll say add. Now I'll enter this URL which I just copied it from my browser. Okay, and then I'll just say start recording. So what it did was, since I've entered the URL in this address box, it just opened the amazon.in URL. Now let's do our test case. So in my test case, what I said was I want to search for iPhone. Once I have this, I'm just going to click on my search button. So now this gives me a list of all iPhones. And then I said I want to add an assertion on the title of this page. So for me to do that, what ID gives me an option is I have to just right click anywhere on this page and you'll see the Selenium ID options here. So in this, I will select assert title and then I will close this browser. So that kind of completes my test case. So now take a look at all the steps which is created for me. So it says open / because I've already provided the URL here. So either you can replace it with your regular URL or you can just leave it as it is. So what I will do, since this is going to be a proper script and I might be using this to run it from my command prompt also. So I'll just replace this target with the actual URL. And then what it is doing, it is setting a window size. Then there are whatever I did on that particular URL on that website, it has recorded all the steps for me. So this is where it says type into this particular text box, which is my search box. And what did it type? iPhone. This was the value which I entered. Now there was one more feature which I told you in this new ID, which I said it has a failover mechanism for your locating techniques. Now that is what this is. Now if you look here, this ID is equal to 2 tab search text box. This is nothing but that search box where we entered the text iPhone. And it has certain identification through which this IDE identifies that web element. And that has multiple options to select that particular search box. So right now what it has used is ID is equal to 2 tab search box. However, if you know the different locating techniques, you will be able to see here that it has other techniques also which it has identified, like the name and the CSS and the XPath. So how does this help in failover is, say tomorrow if Amazon.in website changes the ID of this element, right? You are not going to come and rewrite the scripts again. Instead, by using the same script, what it will do is, if this particular ID fails, if it is unable to find the element using the first locator, which is the ID, it simply moves to the next available ones and it tries to search for that element until one of these becomes true. That is what was the failure mechanism which has got added now. It's a very brilliant feature because most of our test cases break because of element location techniques. Well, let's come back to this. So then we added an assert title, right? So what is assert title here? It simply captures the title of that particular page and it checks. This is all. A very simple test case. So what we will do now is we will stop the recording and then I've also given a close browser. So right now what I will do is I'll just comment this out. Why? Because if I just run this test case, it's going to be very fast and you might not be able to catch the exact command execution what has happened. Alright, so right now I'll just disable it so that it will just do all these test cases and it just stays there without closing the browser. So now I'll just say run the current test case. So your Amazon in is launched. Okay, it is typed in the iPhone. It's also clicked on the search. So it is done. So now if you look here, since we are in the reference tab, it is not able to show. So let's go to the log. And now let's see the log. So it's going to be a running log. So if you notice here, the previous examples which we have run for Facebook is also in the same log. So we will have to see the log from running Amazon search because that's our test case. So if you see here, every command line, right, was executed successfully. Assert title was also done and your test case was executed successfully. So it passed. Now what we will do is on this assert title, I'll just modify this and let's say just add some text. I'll just add SS here. Now this by intentionally I'm going to fail this test case just to show you that whenever there is a test case failure, how does the IDE behaves and how do you get to know the failures. Alright, so I'll just run the test case again. So before that, let's close the previous window. Alright, done. And now here I'll also uncomment the close because anyway it's a failure which I'm going to see, which I should be able to see it in the logs. So I'll close the browser after the execution of test case. Okay, so let's simply go and run the test case. Okay, Amazon.in is launched. It should search for iPhone now. Yeah, there you go. All right, now it should also close the browser. Yes, it has closed the browser and it has failed. Now see here. Now this is the line where our command failed. Why? Because the expected title was not there. And if you look in the logs, it says your assert title on Amazon.in failed. Actual result was something different and it did not match with what we had asked it for. So this is how simple it is to use your IDE to create your automation scripts. So we saw all the components of IDE. We saw the record button, then I showed you the toolbar, I showed you the editor box and also the test execution log. So now let's come to what are the limitations of this IDE. With IDE, you cannot export your scripts, your test scripts to WebDriver scripts. This support is not yet added, but it is in the works. Data-driven testing, like using your Excel files or reading data from the CSV files and passing it to the script, this capability is still not available. Also, you cannot connect to database for reading your test data or perform any kind of database testing. With Selenium WebDriver, yes, you can. Also, unlike Selenium WebDriver, you do not have a good reporting mechanism with the IDE, like say for example TestNG or ReportNG. So that brings us to the next component of the suite, which is Selenium RC, Selenium Remote Control. So Selenium RC was developed by Paul Hammond. He refactored the code which was developed by Jason and was credited with Jason as a co-creator of Selenium. Selenium Server is written in Java. It is used to write web application tests in different programming languages, as it supports multiple programming languages like your Java, C#, Perl, Python and Ruby. It interacts with the browser with the help of an RC server. So this RC server uses a simple HTTP GET and POST request for communication. And as I said earlier also, Selenium RC was called as Selenium 1.0 version. But it got deprecated in Selenium 2.0 and was completely removed in 3.0, and it got replaced by what? WebDriver. And we'll see why this happened and what was that issue which we had with the RC server. So this is the architecture of Selenium Remote Control at a very high level. So when Jason Huggins introduced Selenium, you know the tool was called as JavaScript program. And then that was also called as a Selenium core. So every HTML has a JavaScript statements which are executed by web browser, and there is a JavaScript engine which helps in executing this command. Now this RC had one major issue. Now what was that issue? Say for example, you have a test script, say test.javascript here, which you are trying to access elements from anywhere from the google.com domain. So what used to happen is every element which is accessible are the elements which can belong only to google.com domain. Like say for example mail, the search or the drive. So any elements from this can be accessible through your test scripts. However, nothing outside the domain of say google.com in this case was accessible. Say for example, if your test scripts wanted to access something from yahoo.com, this was not possible. And this is due to the security reasons, obviously. Now to overcome that, the testers, what they had to do was they had to install the Selenium core and the web server, which contained your web application which is under test on the same machine. And imagine if you have to do this for every machine which is under test. This is not going to be feasible or even effective all the time. And this issue is called as a same origin policy. Now what a same origin policy issue says is it prohibits a JavaScript from accessing elements or interacting with scripts from a domain different from where it is launched. And this is purely for the security measure. So if you have written a scripts which can access your google.com or anything related to google.com, these scripts cannot access any elements outside the domain. Like as we said in the example yahoo.com. This was the same origin policy. Now to overcome this, what this gentleman did was he created something called as Selenium Remote Control Server to trick the browser in believing that your core, your Selenium core and your web application under test are from the same domain. And this is what was the Selenium Remote Control. So if you look at again a high level architecture or how did this actually work, first you write your test scripts, which is here, right, in any of the supported language like your PHP or your Java or Python. And before we start testing, we need to launch this RC server, which is a separate application. So this Selenium server is responsible for receiving the Selenese commands. And these Selenese commands are the ones which you have written in your script. It interprets them and reports the result back to your test. So all that is done through your RC server. The browser interaction which happens through RC server, right, from here to your browser. So this happens through a simple HTTP and post and get request. And that is how your RC server and your browser communicate. And how exactly this communication happens? This RC server, it acts like a proxy. So say your test scripts asks to launch a browser. So what happens is this commands goes to your server and then your RC server launches the browser. It injects the JavaScript into the browser. Once this is done, all the subsequent calls from your test script, right, from your test scripts to your browser goes through your RC. And now upon receiving these instructions, your Selenium core executes these actual commands as JavaScript commands on the browser. And then the test results are displayed back from your browser to your RC to your test scripts. So the same cycle gets repeated, right, until the complete test case execution is over. So for every command what you write in your JavaScript here or your test script here goes through a complete cycle of going through the RC server to the browser, collecting the results again from the RC server back to your test scripts. So this cycle gets repeated for every command until your complete test execution is done. So RC had definitely a lot of shortcomings, and what are those? So RC server needs to be installed before running any test scripts, which we just saw. So that was an additional setup since it acts as a mediator between your commands, which is your Selenium commands, and your browser. The architecture of RC is complicated. Why? Because of its intermediate RC server, which is required to communicate with the browser. The execution of commands takes very long. It is slower. We know why. Because every command in this takes a full trip from the test script to your RC server, to the core engine, to the browser, and then back to the same route, which makes your overall test execution very slow. Lastly, the APIs supported by RC are very redundant and confusing. So RC does have a good number of APIs. However, it is less object oriented. So they are redundant and confusing. Say for example, say if you want to write into a text box, how and when to use a type key command or just a type command is always confusing. Another example is some of the mouse commands, using a click or a mouse down. Both kind of, almost providing a similar functionality. So that is the kind of confusion which developers used to create. Hence, Selenium RC got deprecated and is no more available in latest Selenium versions. It is obsolete now. Now to overcome these shortfalls, WebDriver was introduced. So while RC was introduced in 2004, WebDriver was introduced by Simon Stewart in 2006. It's a cross-platform testing platform, so WebDriver can run on any platform like say Linux, Windows, Mac, or even if you have a Ubuntu machine, you can run your Selenium scripts on this machine. It is a programming interface to run test cases. It is not an IDE. And how does this work actually? So test cases are created and executed using web elements or objects using the object locator and the WebDriver methods. So when I do a demo, you will understand what these WebDriver methods are and how do we locate the web elements on the web page. It does not require a core engine like RC. So it is pretty fast. Why? Because WebDriver interacts directly with the browser and it does not have that intermediate server like the RC had. So each browser, in this case, what happens is each browser has its own driver on which the application runs. And this driver is responsible to make the browser understand the commands which you will be passing from the script. Like say for example, click of a button or you want to enter some text. So through your script, you tell which browser you want to work with, say Chrome, and then the Chrome driver is responsible for interpreting your instructions and to execute it on the web application launched on the Chrome browser. So like RC, WebDriver also supports multiple programming languages in which you can write your test scripts. So another advantage of WebDriver is it supports various frameworks like TestNG, JUnit, NUnit and ReportNG. So when we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. So let's look at the architecture of WebDriver at a high level. What is in WebDriver? So WebDriver consists of 4 major components. The first one is we have got client libraries, right? Or what we also call it as language bindings. So since Selenium supports multiple languages and you're free to use any of the supported languages to create your automation script, these libraries are made available on your Selenium website, which you need to download and then write your scripts accordingly. So let's go and see from where do we download this. So if I go to my browser, so seleniumhq.org, right? So if you're working with Selenium, this website is your Bible. So anything and everything you need to know about Selenium, right? You need to come here and use all the tabs here in this website. So right now what we are going to look at is what are those language bindings. So for that, I'll have to go to this download tab here, okay? And if you scroll down here, you will see something like Selenium client and WebDriver language bindings. And for each of the supported language of Selenium, you have a download link, right? So say for example, if you're working with Java here, what you need to do is you need to download your Java language binding. So let's go back to the presentation. So this is where your language bindings are available. Next, so Selenium provides lots of APIs for us to interact with the browser. And when we do the demo, I'll be showing you some of these APIs, right? And these are nothing but the REST APIs. And everything, whatever we do through the script happens through the REST calls. Then we have a JSON wire protocol. What is JSON? JavaScript Object Notation. It is nothing but a standard for exchanging data over the web. So for example, you want to say launch a web application through your script. So what Selenium does it creates a JSON payload and posts the request to the browser driver. That is here. And then we have this browser drivers themselves. And as I said, there is a specific driver for each browser. As you know, every tool has its own limitation. So does Selenium. So let's look at what these limitations are and if there are any workarounds for them. Cannot test mobile applications requires framework like APM. Selenium is for automating web application. It cannot handle mobile applications. Mobile applications are a little different and they need its own set of automation tool. However, what Selenium provides is a support for integrating this APM tool, which is nothing but a mobile application automation tool. And using APM and Selenium, you can still achieve mobile application automation. And when do you usually need this? When your application under test is also supported on mobile devices, you would want a mechanism to run the same test cases on web browser as well as your mobile browsers, right? So this is how you achieve it. The next limitation, so when we talked about the components of Selenium, I said that with WebDriver, we can achieve only sequential execution. However, in real-time scenario, we cannot just live with this. We need to have a mechanism to run our test cases parallelly on multiple machines as well as on multiple browsers. So though this is a limitation of WebDriver, but what Selenium offers is something called as grid, which helps us achieve this. And we will see in shortly what the Selenium grid is all about. Also, if you want to know more details as how do we work with the grid, how do you want to install that grid, so do check out our video on Simplilearn website on Selenium grid. Third limitation, so limited reporting capability. So Selenium WebDriver has a limited reporting capability. It can create basic reports, but what we definitely need is a more. So it does support some tools like say TestNG, ReportNG and even Extent reports, which you can integrate with Selenium and generate beautiful reports. Powerful, isn't it? Also, there are other challenges with Selenium, like Selenium is not very good with image testing, especially for the ones which are designed for web application automation. But then we have other tools which can be used along with Selenium like AutoIt and Securely. So if you look at all this, Selenium still provides a complete solution for your automation needs. And that's the beauty of Selenium, and that is why it makes the most popular tool of today for automation. Okay, let's do a quick comparison between the Selenium RC and the WebDriver. So RC has a very complex architecture. You know why? Because of the additional RC server. Whereas due to direct interaction with the browser, WebDriver architecture is pretty simple. Execution speed. It is slower in RC and much faster in WebDriver. Why? Because in WebDriver, we have eliminated that complete layer of Selenium server, right? That the RC server, and we established a direct communication with the browser through browser drivers. It requires an RC server to interact with the browsers. We just talked about it. And whereas WebDriver can directly interact with the browser. So RC, again, we talked about this as one of the limitations, that we have a lot of redundant APIs, which kept developers guessing as which API to use for what functionality. However, WebDriver offers pretty clean APIs to work with. RC did not offer any support for headless browser, whereas in WebDriver, you do have a support for using headless browsers. Let's see the WebDriver in action now. Now for the demo, we will use this particular use case. And what this use case says is navigate to the official Simplilearn website. Then type the Selenium in search bar and click on it, and click on the Selenium 3.0 training. So we are basically searching for Selenium 3.0 training on the Simplilearn website. First, let's do the steps manually, and then we will go ahead and write the automation script. So let's go to my browser. On my browser, what I'll do is let me first launch the Simplilearn website. Okay, and here what my use case step says is I need to search for Selenium and click on the search button. So once I do that, it is going to give me a complete list of all kind of Selenium trainings which is available with Simplilearn. And what I'm interested in is this Selenium 3.0 training here. Once I find this on the web page, I need to go and click on that. Alright. So this is all the steps which we are going to perform in this use case. Okay. Now, so for writing the test cases, I'll be using an IDE which is Eclipse. I've already installed my Eclipse, and also I have installed Selenium in this instance of my Eclipse. Alright. So if you can see the reference library folder here, you will see all the jars which are required for the Selenium to work. Next, another prereq which is required for Selenium, and that is your driver files. Now, every browser which you want to work with has its own driver file to execute your Selenium scripts. And since for this demo, I'll be working with the Firefox browser, I will need a driver file for Firefox. Now, driver file for Firefox is the Gecko driver, which I have already downloaded and placed in my folder called drivers. Now, where did I download this from? Let's go ahead and see that. So if I go back to my browser, and if you go to your seleniumhq.website, you have to go to this download tab here. In the download tab, when you scroll down, you will see something like third-party drivers, bindings and plugins. In this, you will see the list of all the browsers which is supported by Selenium. And against each of this browser, you will find a link which has the driver files. Now, since we'll be using the Gecko driver, this is the link where you need to go to, and depending on which operating system which you're working on, you need to download that particular file. Now, since I'm working on Mac, this is the file which I'm using. If you're a Windows user, you need to download this zip file and unzip it. So once you unzip that, you would get a file called Gecko driver for your Firefox or a Chrome driver for your Chrome browser. And then what you do is you just create a directory called drivers under your project and just place the driver files here. So these are the two prereqs for your Selenium. One is importing your jar files like this, and then having your drivers downloaded and keep them under a folder where you can reference to. Okay. So now we'll go ahead and create a class. I already have a package created in this project. So I'll use this project and create a new class. So I'll say create new Java class, and let's call this as search training. I'll be using a public static void main, and I'll click on finish. So let's remove this auto generated lines as we do not need them. Alright. Now the first statement which you need to write before even you start writing the rest of your code is what you need to do is you need to define or declare your driver variable using your class WebDriver. So what I would do is I'll say WebDriver driver. Done. Alright. Now you will see that this IDE is going to flash some errors for you. That means it is going to ask you to import certain libraries which is required by the WebDriver. So simply just go ahead and say import WebDriver from org.opensq.selenium. This is the package which we will need. Alright. So you have a driver created which is of the class WebDriver. And now after this I'm going to create three methods. Alright. So first method I will have for launching the Firefox browser. Okay. And then I will write a simple method for searching Selenium training and clicking on it. This is the actual use case what we'll be doing. And then third method I'm going to write is just to close the browser which I'm going to be opening, right? So these are the different methods which I'll be creating, and from the public static void main I will just call these methods one after the other. Okay, so let's go ahead and write the first method. Now my first method is launching the Firefox browser. So I'll say public void, since my return type is null or there is no return type for this, let's call it as launch browser. Okay, alright. Now in this, for launching any browser, I need to mention two steps. Now the first step is where I need to do a system.set property. Okay, let's do that first and then I'll explain what this does. I'll just say system.set property. So this accepts a key and a value pair. So what is my key here? My key here is webdriver.gecko.driver, and I need to provide a value. So value is nothing but the path to the Gecko driver. And we know that this Gecko driver which I'm going to use here is right here in the same project path under the drivers folder, correct? And that is what the path which I'm going to provide here. So here simply I need to say drivers/Gecko driver. Gecko. Alright. Done. And let me close this sentence. Alright. Now since I'm a Mac user, my Gecko driver installable is just the name Gecko driver. If you're a Windows user and if you're running your Selenium scripts on the Windows machine, you need to provide a complete path to this, including .exe, because driver executable on your machines is going to be gecko driver.exe. Alright. So just make sure that your path which you mentioned here in the system.set property is the correct path. Okay. Then the next thing what we need to do is, I need to just say driver is equal to new Firefox driver. Okay. So this command, new Firefox driver, creates an instance of the Firefox browser. Now this is also flagging me error. Why? Because again it's going to ask me to import the packages where the Firefox driver class is present. Okay, we did that. Now these two lines are responsible for launching the Firefox browser for me. So this is done. So what's my next step in the use case? Now I need to launch the website Simplilearn. So for that we have a command called driver.get. Driver.get, what it does is, whatever URL you're going to give it here in this double quotes as an argument, it is going to launch that particular website. And for us, it's a Simplilearn website. So what I do as a best practice is, instead of typing out the URL, I go to my browser, launch that URL which I want to test, and I simply copy it. Come back to your Eclipse and just simply paste it. So this ensures that I do not make any mistakes in the URL. Okay, so done. So our first method is ready, where we are launching the browser, which is our Firefox browser, and then launching the Simplilearn website. Now, the next method. What is my next method? In my next method, I need to give the search string to search Selenium training on this particular website. Now, for that, we need to do few things. What are those few things? Let's go to the website again. All right. So let me relaunch this. Let's close this. Okay. Let me remove all this and let's go to the home page first. Okay, this is my home page. So as you saw, when I did a manual testing of this, I entered the text here. So now since I have to write a script for this, first I need to identify what this element is. For that, what I'm going to do is I'm just going to say right click here and I'll say inspect element. Alright, now this element, let's see what attribute it has which I can use for finding this element. So I see that there is an ID present. So what I'm going to do is I'm just going to simply use this ID and then I'll just copy this ID from here. Go back to Eclipse. Let's write a method first. So I'll say public void, and what do we give the method name? Say search training or just search. All right. Now in this, I need to use a command called driver.findElement by ID is what I'm going to use as a locating technique. And in double quotes, the ID which I copied from the website is what I'm going to paste here. Okay. And then what am I going to do on this element is, I need to send that text, the text which I'm going to search for, which is Selenium. So I'll just say send keys, and whatever text I want to send, I need to give it in double quotes. So for that, Selenium. So this is done. So now I've entered the text here, and after entering the text, I need to click on this button. So for that, I need to first know what that button is. So let's inspect that search button. Okay. Now, if you look at the search button, other than the tag, which is span, and the class name, I do not have anything here. All right. So what I can do is I can either use the class name or I can write an XPath. Since this is a demo, which we have already used ID locating technique, I would go ahead and use the XPath here. So for me to construct an XPath, I will copy this class first. Okay. And then I already have a crow path installed on my Firefox. So I'll use the crow path and first test my XPath. So I'll just say /. Let's see what was that element. It has a span tag. Okay. So I'll have to use span and at class equal to, and I'll just copy the class name here. And let's see if it can identify that element. Yeah. So it is able to identify. So I'll just use this XPath in my code. So I'll go back to Eclipse and I'll say driver.findElement by.xpath. And the XPath which I just copied from crowpath is what I'm going to paste here. And what is the action I need to do here? I need to say click. Done. So I have reached a stage where I've entered this Selenium. Okay. And then I have clicked on the search button. Once I do this, I know that expected result is I should be able to find this particular link here, Selenium 3.0 training. Okay. And I should be able to click on that. So for that, again, I need to inspect this. So let's inspect this Selenium 3.0. Alright, so now what are the elements this has? Now this particular element has attributes like it has a tag Ec2, then it has got some class name and some other attributes. So I would like to use a XPath here. Now this time while using the XPath, I'm going to make use of a text functionality so that I can search for this particular text. So I'll simply copy this. I'll go to my crow path. The tag is H2. So I'll say simply H2. Okay. And here I'll say text equal to, and this is the text which I copied. I missed out that yes there. So I'm just going to add an S. Okay. So let's first test here whether it is able to identify that element. Yeah. So it is able to identify. So can you see a blue dotted line? It is able to show us which element it is identified. So I'll copy this X path now, and let's go to my IDE Eclipse. So now here what I need to do is I'll have to again simply say driver dot find element by dot XPath and paste the XPath which we just did, and then again I have to do a click operation. Done. Alright. So technically we have taken all the steps of the use case and we have written the commands for that. Alright. Now let's add an additional thing here. Say after coming to this page, after finding this, we want to say print the title of this page. Now what is the title of this page? If you just hover your mouse on this, it says online and classroom training for professional certification courses Simplilearn. So what I will do is after doing all these operations, I will just print out this page title on our console. So for that I have to just do this driver dot so let's do a sysout. So I'll say sysout system.out.println. Okay, and here I would say let's add a text here. The page title is, and then let's append it with driver dot get title. So this is the command which we'll be using to fetch the page title. Done. Now what is the last method I need to add? Just to close the browser. Alright, so let me add a method here. I'll say public void close browser, and it's a one single command which I need to call. I'll say driver dot quit. Okay, and then I need to call all these methods from my public static void main. So I'll let me use my class name, which is this. So I'm going to create an object obj is equal to new class name, and then using this object, first is I need to call the method launch browser, and then I'll call the method search, right, and then I'll call the method close browser. Done. So technically our script is ready with all the functionality which we wanted to cover from our use case. Now there are few other tweaks which I need to do this, and I'll tell you why I need to do this. Now for example, after we click here, right, after we click on the search, if you observed on your website, it took a little while before it listed out all the Selenium trainings for us. And usually when you're actually doing it, you wait for the Selenium 3.0 training to be available and then you click on that. Now same thing, you also need to tell your scripts to do that. You need to tell your scripts to wait for a while until you start seeing the Selenium 3.0 training or it appears on your web page. There are multiple ways to do that in your script, and it is a part of overall synchronization, what we call, where we use kind of implicit and explicit kind of ways. Now since this is a demo, for demo purpose, what I'm going to do is I'm going to use a command called thread.sleep, and I'm just going to give an explicit wait of say 3 seconds. So you can use this mainly for the demo purposes. You can use a thread.sleep command. Now this thread.sleep command needs us to handle some exceptions. So I'm just going to click on add throws declaration and say interrupted exception. Now same thing, I'll have to do it in my main function also. Okay, so let's do that and complete it. Alright, so this is done. So by doing this, what am I doing? I'm ensuring that before I click on the Selenium 3.0 training, we are giving enough time for the script to wait until the web page shows this link to the Selenium 3.0 training. That's one thing I'm doing. Alright, and also now since you're going to be seeing this demo through the video recording, the script when it starts running, it is going to be very fast. So you might just miss out seeing how it does the send keys and how did it click on the search button. For us to enable us to see it properly, I'll just add some explicit waits here just for our demo purpose. So after entering the keys, right, so what I'll do is I'll just give a simple thread.sleep here. Okay, so probably a 3 seconds or a 2 seconds wait should be good enough. Okay, a 3 seconds wait should be good enough here so that we should be able to see how exactly this works on your browser when we execute this. Okay, now our complete script is ready. So what I'll do is I'll just save the script and then we will simply run the script. So to run the script, I'll just say right click, run as Java application. Okay, it says asks me to select and save. I've saved the script now. So let's observe how it runs. Okay, the Simplilearn.com, the website is launched. So the Selenium text has been entered in the search box. It is clicked on the search. Okay, all right. So now it did everything whatever we wanted it to do. All right. So since we are closing the browser, you were unable to see whether the Selenium 3.training was selected or not. However, what I have given here is to fetch the title after all these operations were complete. And if you see here, the complete operations was done and we were able to see the page title here. Okay. So now what I'll do, since we are unable to see whether it clicked on the Selenium 3.0 training or not, I'll just comment out the close browser, the command. Okay. So we will not call the close browser so that the browser remains open and we get to see whether did it really find the training link or not. Okay. So let me close this window. We don't need this Firefox window. Close all tabs and then I'll just re-execute this script. So I'll say run as Java application. So save the file. Okay, Simplilearn.com is launched. So search text is entered. Now it's going to click on the search button. Yes. All right. So we have got the search results. It should click on Selenium 3.0 training and yes, it is successfully able to click on that. All right. So now it's not going to close the browser because we have commented on that line. However, it did print us the title here. All right. So this is a simple way of using the Selenium scripts. Selenium Grid. So Grid is used to run multiple test scripts on multiple machines at the same time. With WebDriver, you can only do sequential execution, but in real-time environment, you always have the need to run test cases in distributed environment, and that is where Selenium Grid comes into picture. So Grid was conceptualized and developed by Patrick. The main objective is to minimize test execution time. And how? By running your test parallelly. So design is in such a way that commands are distributed on multiple machines where you want to run test and all these are executed simultaneously. What do you achieve by this methodology? Of course, the parallel execution on different browsers and operating system. Grid is pretty flexible and can integrate with many tools. Like say you want a reporting tool integrated to pull all the reports from the multiple machines where you're running your test cases and you want to present that report in a good looking format. So you have an option to integrate such report. Okay, so how does this Grid work? So Grid has a hub and node concept which helps in achieving the parallel execution. Let's take an example. Say your application supports all browsers and most of the operating system. Like as in this picture, you could say one of them is a Windows machine, one of them is a Mac machine and another one is say a Linux machine. So your requirement is to run the test on all supported browsers and operating systems like the one which is depicted in this picture. So what you have to do is, first thing is you configure a master machine or what you also call it as a hub by running something called a Selenium standalone server. And this standalone server can be downloaded from the Selenium HQ website. Using the server, you create a hub configuration, that is this node. And then you create nodes specific to your machine requirement. And how are these nodes created? You again use the same server, which is your standalone Selenium server, to create the node configuration. So I'll show you where the Selenium server can be downloaded. So if we go back to our Selenium HQ website, so you can see here right on the top, it says Selenium standalone server. And this is the latest version available. So you just need to download. Once you download this, keep a version of this one on your master machine, that is your hub, and this should also be present on your node machines. And there is a certain command which you can use to install this server as a node and as a master depending on your configuration. So once that is done, you have your master or the hub and the nodes created. Your master can control on which nodes you want to execute test. Now say if this is a Mac machine, this is a Windows machine, through your master or your hub, you control on which machine you want to execute what tests. Then also you could have a multiple combination of tests. Like say for example, smoke test to be run on all these nodes. That's the kind of configuration you can create. Or a certain component test to be run on say only Windows 10 with an Edge browser. Or say regression test on Mac machine. So any such things, whatever configurations you have for your node, what happens is the hub picks the right node which conforms to your requirements or the configurations which you have set up, and then sends a command to the node to execute those test cases on the node. Everything is controlled through your master machine only here. What happens on the node? So once the node gets the command from the master, the node actually runs all the test cases which it intends to run on the specific browser which you have mentioned in your configuration file. So this is a very high level architecture and how a grid works. So if you want to know more details of how the grid works, you can refer to our video on Simplilearn. Alright, again, limitations. So what limitation does this grid have now? The first one, it has relatively poor scalability compared to many modern applications. It is pretty static. Each server is configured in advance with a subset of required browser instances available. So if you want to vary this, you'll need to reconfigure. So any configuration tomorrow on any machines you want to change, it cannot be done automatically. You need to completely reconfigure that node and then add it back to the grid. Thirdly, although it is available to run on virtual servers, it is actually not designed as a cloud native application. And as a result of this, it isn't optimized to take advantage of things like say distributed storage or dynamic scaling or even automatic failover. So these are some of the limitations of the grid. Advantages of Selenium: speed and accuracy. Of course, since there is no manual execution, your test can run faster, and with grid, it helps in parallel execution, and you can run or execute large volumes of tests within a very short time frame. Let's take an example. Say just before the release of your product, say during the last lap of your testing, you find a bug, and of course it has to be fixed. So the developer fixes the bug and you want to run all the test cases pertaining to that area. Now, can you imagine that if you have to do this testing manually, how long it's going to take? So by automation, you can achieve this in a very short duration of time, and it will also help you release your product in time with very minimal or absolutely no human errors. The second advantage, it's an open source, so it's available free of cost, so anyone can download it and start using it. It supports wide spectrum of programming languages we have been seeing throughout this presentation. It is not restricted to any particular programming language. So whatever language you are comfortable with, you have an option to use that and write your Selenium scripts. Selenium has support for almost all browsers and operating systems. We also talked about headless browser support. So this helps you create test cases once using any of the browser and run them across all browsers and all operating systems, thus saving you a lot of time from manual execution and helping in achieving a very broad test coverage. And we also saw that pretty easy to use tool, right? So you can check out all our videos and it's just a matter of time that you can master the skill of writing your automation scripts. Reusability. Of course, like any programming language, it provides you a mechanism to reuse your code and avoid redundancy. Well, again, let's see an overall what are the limitations of Selenium itself. Now, since Selenium is open source, that is one of the biggest advantage. Now, there is a little disadvantage which comes with that. And what is it? You do not have much technical support because it's an open source code. However, there are loads and loads of documentations and forums available which you can definitely refer to. And Selenium, as we said, it is only for automating web applications. It cannot handle the mobile applications or even the desktop application. However, it does provide support for integrating tools like APM for mobile testing. Selenium is not very good with image testing, especially designed for your web application tools. Again, we have tools like AutoIt and Securely which can be integrated with Selenium. Selenium WebDriver has limited reporting capability, but again, it does provide us support for integrating tools like TestNG, ReportNG and Extend Report. It does not have test management capabilities. It need not, right? Not one tool need not have each and everything what is required, but there is always a way to integrate it. So Selenium does provide a way to integrate any of the test management tools. Now, since Selenium supports multiple programming languages, the developer of test automation will require to have some basic knowledge of any of the programming language it supports to write effective automation scripts. Right? So this you could look at it as an advantage or as a disadvantage. So overall, if you look at all this, right, Selenium still provides a complete solution for our automation need. And that is why we can still say that Selenium is one of the most popular tool used in the industry today for your web application automation.
What Docker is and how you could be using it within your own DevOps environment. So let's get started. So let's first of all compare Docker with a traditional virtual machine. So here we have the architecture on the left and right of a traditional virtual machine versus a Docker environment. And there are some things that you'll probably see immediately that are big differences. One is that the virtual environment has hypervisor layer, whereas the Docker environment has a Docker engine layer. And then in addition to that, there are additional layers within the virtual machine. Each of these really start compounding and creating very significant differences between a Docker environment and a virtual machine environment. So with a virtual machine, the actual memory usage is very high, whereas with a Docker environment, the memory usage is very low. If we look at performance, virtual machines, when you start building out particularly more than one virtual machine on a server, the performance starts degrading and starts getting poorer, whereas with Docker, the performance always stays really good. This is largely due to the lightweight architecture used to construct the Docker containers themselves. If we look at portability, virtual machines just are terrible for portability. They're still dependent on the host operating system, and there's just a lot of problems that happen when you are using virtual machines for portability. In contrast, Docker was designed for portability, so you can actually build solutions in a Docker container environment and have the guarantee that the solution will work as you have built it, no matter where it's hosted. Finally, boot up time. The boot up time for a virtual machine is fairly slow in comparison to the boot up time for a Docker environment, which is almost instantaneous. So we look at these in a little bit more detail. One of the other challenges that you have with a virtual machine is that if you have unused memory within the environment, you cannot reallocate that memory. So if you set up an environment that has 9 gigs of memory that's being used, but you have 6 gigs that are free, you can't do anything with it. Though that whole 9 gig has been allocated to that virtual machine. In contrast with Docker, if you have 9 gigs and 6 gigs becomes free, that free memory can then be reallocated and reused across other containers used within that Docker environment. Another challenge is running multiple virtual machines in a single environment can lead to instability and performance issues, whereas Docker is designed to run multiple containers in the same environment and actually gets better the more containers you run in that hosted single Docker engine. Portability issues with a virtual machine is the software can work on one machine, but then when you move that VM to another machine, suddenly some of the software won't work because there are some dependencies that haven't been inherited correctly. Whereas Docker itself is designed specifically to be able to run across multiple environments and to be deployed very easily across the systems. And again, the actual boot up time for a VM, it just takes a long time. You're talking about minutes in contrast to the milliseconds that it takes for a Docker environment to boot up. So let's dig into what Docker actually is and what allows for these great performance improvements over a traditional VM environment. So Docker itself is an OS virtualized software platform, and it allows IT organizations to really easily create, deploy, and run applications as what are called Docker containers that have all of the dependencies within that container very easily. And the container itself is really just a very lightweight package that has all the instructions and dependencies such as frameworks, libraries, bins, etc., all within that container. And that container itself can then be moved from environment to environment very easily. If we to look in our DevOps lifecycle, the place where Docker really shines is in deployment, because when you're actually at the point of deploying your solution, you want to be able to guarantee that the code that has been tested will actually work in the production environment. But in addition to that, what we often find is that when you're actually building the code and you're actually testing the code, having a container running the solution at those stages is also a really good plus, because what happens is that the people building the code and testing the code are able to validate their work in the same environment that would be used for the production environment. So really, you can use Docker in multiple stages within your DevOps cycle, but it becomes really valuable in the deployment stage. So let's look at some of the key advantages that you have with Docker. Some of the things that we've already covered is that you can do rapid deployment, and you can do it really fast. The environment itself is highly portable and was designed for that in mind. the efficiencies that you'll see will allow you to run multiple Docker containers in a single environment as compared to more traditional VM environments. The configuration itself can be scripted through a language called YAML, which allows you to be able to write out and describe the Docker environment that you want to create. This in turn allows you to be able to scale your environment very, very quickly. But with all of these advantages, probably the one that is most critical to the type of work that we're doing today is security. You have to ensure that the environment you are running is a highly secure but highly scalable environment. And I'm very pleased to say that Docker takes security very seriously. So you'll see it as one of the key tenets for the actual architecture of the system that you're implementing. So let's look at how Docker actually works within your environment. So Docker works, there is what's called a Docker engine. The Docker engine is really comprised of two key elements. You have a server and a client, and the communication via the two is via REST API. The server, as you can imagine, has the instructions that are communicated out to the client and instructs the client on what to do. The connection between the client and the server, the communication, is via a REST API. On older systems, you can take advantage of the Docker toolbox, which allows you to go ahead and control the Docker engine, the Docker machine, Docker Compose, and Kitematic. So let's now go into what the actual root components, though, of Docker are. So let's have a look at those key components. There are four components that we're going to go through. We have the Docker client and server, we have Docker images, we have the Docker registry, and the Docker container. We're going to step through each of these one by one. So let's look at the Docker client and server first. So the Docker client and server is a command line instructed solution where you would use terminal on your Mac or command line on your PC or Linux system to be able to issue commands from the Docker daemon. The communication between the Docker client and the Docker host is via a REST API. So you can do similar communication such as a Docker pull command, which would send an instruction to the daemon, which would then form the interaction of pulling in the correct components, such as an image or container or registry, to the Docker client. The Docker daemon itself is actually a service which actually performs all sorts of operating and performance services. And as you'd imagine, the Docker daemon is constantly listening across the REST API to see if it needs to perform any specific requests. If you want to trigger and start the whole process, what you want to do is use the command dockered within your Docker daemon, and that will start all of your performances. And then you have a Docker host, which actually runs the Docker daemon and registry itself. So now let's look into the actual structure of a Docker image. So a Docker image itself is a template which contains instructions for the Docker container, and that template is written with a language called YAML, and YAML stands for yet another markup language. It's very easy to learn. The Docker image itself is built within that YAML file and then hosted as a file in the Docker registry. The image is really comprised of several key layers. And you start with your base layer, which will typically have your base image. In this instance, it's your base operating system, such as Ubuntu. And then you would then have layer of dependencies above that. This would then comprise the instructions in a read-only file that would become your Docker file. So let's actually go through and look at what one of those sets of instructions would look like. So here we have 4 layers of instructions. We have a from, pull, run, and then command. So what does that actually look like in our layers? So to break this down, the from creates a layer which is based on Ubuntu. And then what we're doing is we're adding in files from the Docker repository onto that base command, that base layer. And then what we want to be able to do is then say, okay, what are the run commands so we can actually then build the container within the environment. And then we want to be able to then have a command line that actually executes something within that container. And in this instance, the command is to run Python. So one of the things that we will see is that as we set up multiple containers, each new container is a new layer with new images within the Docker environment. Each container is completely separate from the other containers within your Docker environment. So you're able to create your own separate read-write instructions within each layer. What's interesting is that if you delete a layer, then the layer above it will also get deleted. So what happens when you pull in a layer, but something has changed in the core image? What's interesting then is that the actual main image of itself cannot be modified. Once you've copied the image, you can then modify it locally, but you can never modify the actual base image itself. So here are some callouts for the components within a Docker image. So the base layer are in read-only format. The layers can be combined in a union file system to create a single image. The union file system saves memory space by avoiding duplication of files. And this allows a file system to appear as a writable, but without modifying the file, which is known as a copy on write. The actual base layers themselves are read-only. So to be able to get around this structure within a Docker container, the Docker environment itself uses what's known as a copy on write strategy within the images and the containers themselves. And so what this allows you to do is you can actually copy the files for better efficiency across your entire container environment. The copy and write strategy does make Docker super efficient, and what you're able to do all the time is keep reducing the amount of disk space you're using and the amount of performance that you're taking from the server. And that's really, again, a key element for Docker, is just this constant ability to be able to keep improving the efficiency within the actual system itself. All right, so let's go on to item number 3, which is the Docker registry. So the Docker registry itself is the place where you would host and distribute the different types of images that you have created or you want to be used within your environment. The actual repository itself is just a collection of Docker images, and those Docker images are built on instructions that you would write with YAML and are very easily stored and shared. And what you can actually do is you can actually associate specific name tags to the actual Docker images themselves. So it's easy for people to be able to find and share that image within the Docker registry itself. One of the things you actually see as we go through the demos, you actually see us actually using the tag name, and you'll see how it is an alphanumeric identifier and how we actually use it to actually create the actual container itself. One of the things you can do to as start off how you would manage a registry is you can actually use the publicly accessible Docker Hub registry, which is available to anybody, but you can also create your own registry for your own use internally. The actual registry that you create internally can have both public and private images that you create, and this may be for various reasons of how you structure your environment. The actual commands you would use to actually connect to the registry are both push and pull. Push is to actually push a new container environment that you've created from your local manager node to the remote registry, and a pull allows you to pull a new client that has been created and is being shared. So again, pull command, it pulls and retrieves a Docker image from the Docker registry and makes it very easy for people to share different images consistently across teams. And a push command allows you to take a new command that you created, a new container that you created, and push it to the registry, whether it's Docker Hub or whether it's your own private registry, and allow it to be shared across your teams. Some key did you knows in Docker registry, deleting a repository is not a reversible action. So if you delete a repository, it's gone. So let's go into the final stage here, which is the actual Docker container itself. So the Docker container itself is an executable package of applications and its dependencies bundled together. So it gives all the instructions that you would have for the solution that you're looking to run. It's actually really lightweight, and again, this is because of the redundancy that's built into how you structure the container, and the container itself is then inherently also extremely portable. What's really good about running a container though is that it does run completely in isolation, so you're able to share it very easily from group to group, and you are guaranteed that even if you are running a container, it's not going to be impacted by any host OS peculiarities or unique setups as you would have in a VM or a non-containerized environment. The actual memory that you have on a Docker environment, they can be shared across multiple containers, which is really useful. Typically, when you have a VM, you would have a defined amount of memory for each VM environment. The challenge you start running into, though, is that you can't share that memory, whereas with Docker, you can easily share the memory for a single environment across multiple containers. The actual container is built using Docker images, and the command to actually run those images is a run command. So let's actually go through a basic structure of how you would run a Docker image. So you go into terminal window and you would write in Docker run Redis, and then it would run a container called Redis. So we're going to go in, and if you don't have the Redis image locally installed, it will then pull it from the registry. Then the new Docker container Redis will be then available within your environment, so you can actually start using it. So let's look at why containers are so lightweight. They're so lightweight because they really have been able to get away from some of the additional layers that you have in virtualization within VMs. And the biggest one is the hypervisor and the need to run on a host operating system. Those are two big elements. So if you can get rid of those, then you're doing great. So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service. And it does this by running each container in isolation, but allowing the containers to interact with each other. As was stated earlier on, you would actually write the Compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you would use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the, if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build-t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already. And we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker, and actually we don't want to do image, we want to select pull, and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to head and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded, so we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded, but we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80, and then we'll put in MySQL latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker ps to list all the running containers, and what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a, and yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago, but it's in the exited mode. So what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run -it -name, and we can name it SL SQL MySQL /bin/bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images. Here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that, and it's going to we paste that, it won't be able to actually run correctly because the image is active. So what we have to do now is stop the image and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and just kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run -dit -name white. That's going to be the name of this HTTP service -p 8080:80-v open quotes $pwd close quotes :/usr/local /apache2/htdocs /httpd :2.4. We'll run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name, because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser, and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running.
This is Anjali from Simplilearn, and today we'll dive into a tutorial on the configuration management tool Chef. So if you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy their product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Ops Code. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node, and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine, and two nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have one recipe, two recipes, three recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the Ohai service. The Ohai service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is the Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these 3 machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using 2 virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have 2 machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7, so my operating system version is 7, so I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a Chef repository. So within that, we'll have a folder for holding all our cookbooks, and within our cookbook, we'll write our recipe. So we start with the directory for Chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK. We have a Chef repo folder here. And let's check the contents of this Chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample. And tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes, we have default.rb. So we'll be editing this default.rb to create our recipe. Okay, so let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server. Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you gotta download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we gotta move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done, go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list, and here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file. We look into the tutorial on the configuration management tool Puppet. So let's begin. Why Puppet? So consider the scenario of an MNC. The MNC puts together the small team of system administrators. They're responsible for taking care of the infrastructure of this organization. Now this infrastructure could consist of data centers, server centers, and many such components. Fortunately for the MNC, they were doing extremely well. So the number of clients kept growing consistently, and with this came a boom in the infrastructure size. Now here is where the problem came in. With such a large infrastructure, the small team that they put together in no way could manage this. So what do? The solution seems pretty simple, right? Just increase the size of the team. Sure, we'll increase the size of the team. But when do you think we can put an upper limit on the size? When do we get to stabilize this team? So here is where Puppet comes in. With Puppet, a small team is enough to take care of this large infrastructure. This is because the data centers, server centers, all of them can be updated in a matter of seconds with Puppet. Entire load of doing so has now shifted from the team onto the tool. Not only this, with Puppet, if servers do fail, and there's a very high chance of servers failing when you're considering an organization the scale of an MNC, Puppet can instantly roll them back to their previous working states. And if that wasn't enough, Puppet also provides the capability to deploy servers on demand and enforce security on them. Now all of this is done through simple coding which is written in Ruby. We'll look at how Puppet works more. So now that we know why we should use Puppet, let's have a look at what exactly is Puppet. So first and foremost, Puppet is a configuration management tool, as I already mentioned in the beginning of this video. So this simply means that Puppet ensures that all your systems are maintained at a consistent state. So consider that you want to deploy a number of servers. Now you require these servers to be identical. If this task is given to a human, there's a very good chance that those systems will not be identical, or some of them may even fail. Humans are prone to errors, you cannot blame them. So Puppet ensures that all these servers are deployed on time and they are identical. Secondly, Puppet is also a deployment tool. This simply means that Puppet has the capability to deploy your applications, your services, softwares, all of this on your nodes automatically. And finally, Puppet implements infrastructure as code. Now this term infrastructure as code is a very important one when it comes to the DevOps approach. You would have noticed this term being used in our previous video on Chef 2. If not, you can always click the top right corner to know more. So what does this term infrastructure as code mean? Infrastructure as code simply means that all your policies, your tasks, your instructions, everything is written in coded format. So in case of Puppet specifically, all of this is written in the Ruby language. So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we'll look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as System A. So System A sends over a client certificate to the master. Associated with this client certificate is the host name of System A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the System A. If it does, it signs the certificate and the signed certificate is sent back to System A. Now the System A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first 3 stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. And we reach the final and the most exciting part of our video, which is the hands-on. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using 2 machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created 2 virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate, and then it'll sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the code for configuration, and once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your cat logs, because as you know, the manifests are compiled into cat logs, these are executed on your node, and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine, because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere, because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce the size. .512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet -master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Signed certificate request. Here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo. Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured, and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often, and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks, and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting two virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these two machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy, because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing, we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted. So that was very simple, wasn't it? If you have any doubts about the procedure or any other part of the tutorial, please post your doubts in the comment section below and we'll get back to you as soon as we see them.
We'll provide the overview of how and why you should be using Kubernetes. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster, it's very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. And you really want to let Kubernetes do this because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right-hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left-hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left-hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you would probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's lifecycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filtered, organized, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password, and this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https, and this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency, and the way we do that is write the command sudo apt install docker.io. I've got a typo, correct that quickly, and put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. And we're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc/apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt.kubernetes.io/kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do cat/etc/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path that we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-file.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube/config. And then the final one will be sudo chown $open paren id-u close paren colon $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, I think I have a typo in my command here. Yep. Oh, yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply dash f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network, and so we're going to do that by writing the command sudo kubec tcl get pods dash all dash namespaces, and it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service, and we're going to do that with the command sudo kubectl run -- image equals nginx. And we're going to put this into port 80, so it's going to be nginx-app port equals 80 -- environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app port equals 80 -- name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
In this section, we're going to talk about what is cloud computing and how things were before AWS, and we're going to talk about what is AWS and the benefits of AWS and the products and services that Amazon offers as of now. And then finally, we're going to end this session with a project that is going to help us understand how to create a Jenkins build server for continuous integration. And in this project, we will learn about how to deploy and host Jenkins, an open source automation software predominantly used for CI/CD, otherwise continuous integration and continuous development. So what is cloud computing? Cloud computing is the on-demand delivery of compute resources through a cloud platform accessed via the internet, and it's also a pay-as-you-go service. Be it compute capacity or database or storage, in cloud we access them through the internet, and that too on a pay-as-you-go pricing model. Let's talk about how things were before AWS existed. Expedia, as we know as the people logistic company, or the company that helps people move around the world with ease, has a certain problem before they decided to migrate to AWS. And migrating to AWS was a solution to their problem. Back then, booking ticket was an unpleasant experience compared to what it is now. It generally would take a long time to book a ticket. And sometimes it would time out if there is a promotion or if a huge sale announced, and if the environment is not scaled up to meet the demand. And sometimes it would time out if there is a promotion or if a huge sale announced and they could not scale up the environment and keep up with the speed of the promotion. That's when they got introduced to AWS, and with the AWS power to increase the capacity of the environment on the fly, solved their scaling issue. Instead of waiting on the new hardware to arrive and wondering what to do with the hardware when the promotion is over, with AWS we can quickly scale up the environment when there is a need and scale down the environment during lull periods. Now that being said, let's talk about what is AWS. Amazon Web Services, or in short AWS, is a secure cloud service platform offering compute power, database, content delivery, and other functionality that you would need to help your business scale and grow. AWS is a very secure cloud platform, and such security cannot be imagined in on-premises without spending a fortune. Almost any type of applications can be created and deployed in the cloud, which includes the latest IoT applications, machine learning, artificial intelligence, and so on. And the best part is we can avail this service from anywhere as long as we have an active internet. and all this is availed on pay-as-you-go subscription. Now let's talk about the benefits of AWS. AWS Cloud Platform is very easy to use. One needs no complicated programming or compute knowledge to access and use this environment. Even with less programming and compute knowledge, one could become a pro in accessing and maintaining the cloud. The products and services offered are very flexible in nature, and that provides room for us to easily integrate the service to other services in AWS and services outside AWS. Cloud in general is a very reliable service, and AWS in specific is very reliable. Cloud in general is very reliable, and when we talk about AWS, it's very true. A statistic says that about 95% of the cloud computing in the whole world is run on AWS due to AWS reliable nature. The services in AWS are scalable by nature, and most of the services provide click button scaling. Services in AWS are very cost effective, and it becomes very true when you start using more services in AWS are very cost effective, and it becomes very true when you start using more services in AWS are very cost effective, and it becomes more true when we start using more, since when we start using more service, the per unit price drops down even further. Security in the cloud is at its highest with encryption and multi-factor authentications and being able to audit the logs. One can be sure that when one hosts a service in AWS, they are hosting it in an environment which has been built with enterprise security in mind. Alright, let's now talk briefly about the different products and services available in the cloud. Some of the products and services available in the cloud are compute, storage, database, migration services, networking and content delivery, developer tools and services available for managing the AWS environment, tools needed for machine learning development, analytic tools needed for security and identity compliance, tools needed for mobile application services, tools needed for IoT and gaming development are some of the products that are available in AWS. Alright, let's first talk about compute service. Now, compute service, it enables us to develop, deploy, run and scale our applications and workloads on the cloud. You might agree with me that compute service is the fundamental of any applications, and AWS provides many options to use those compute services in the cloud, starting from Ec2, which is a VM in the cloud, to Lambda, which is serverless computing in the cloud, to compute service. Compute service also includes container services and services that help batch processing and deploying applications and load balancing the request when we run our applications on multiple servers, and services that help batch processing and developing applications and load balancing the request when we run our applications in multiple servers. We're going to talk about two compute products in specific. Let's talk about Ec2. Ec2 is a service with a resizable compute capacity in the cloud that allows business subscribers to run application programs in the computing environment. And the best part here is Ec2 is resizable. Anytime there is more demand, I can simply resize my computer to meet the demand. On the other hand, Lambda is a serverless compute service used to execute backend codes. It really helps us to focus on the core competencies like application building the code. Let's talk about storage service for a while. AWS storage is known for its durability and availability, with S3 being the object storage for the internet, where users or application can directly upload and download the content from the internet, and EBS being a durable block storage that gets attached to the Ec2 instance, and Glacier being the archival solution in the cloud, and Storage Gateway being the gateway for storing data locally and having a backup in the cloud in case of disaster. Let's talk about two important storage service products in the cloud, which is S3. Now, S3 is an web-based cloud storage service. It's designed for online backup and archiving of data. And the best part about S3 is that it provides 11.9 durability, which means once we store the data in S3, the chances of losing the data is nearly zero. EBS, on the other hand, provides persistent and resizable and migratable storage to the VMs or EC2s that we can run in the cloud. Now let's talk about the database offerings in the cloud. Beginning with RDS for SQL and Dynamodb for NoSQL and Elasticache for web caching services and Amazon Redshift for petabyte scale data warehousing services. AWS Database Service provides all the database service needs we might have. Let's talk about two database services in specific. RDS. RDS is an web service that is designed to simplify the setup, operation, and scaling of the relational database in the cloud. And DynamoDB is a fast and flexible NoSQL database service which is well known for its low latency and scalability performance. Network and Content Delivery Service contributes to the infrastructure as a service side of the cloud. It provides a secure cloud infrastructure and connects our physical network to our private virtual network with low latency and high transfer speeds. And under Networking and Content Delivery Services, VPC is Virtual Private Cloud Networking in the cloud. Route 53 is the DNS service in the cloud. And Direct Connect is a service that connects our on-premises with AWS environment through point-to-point cables. And CloudFront is Content Delivery Network or caching service throughout the world. Let's talk about VPC for a while. VPC, it enables us to launch AWS resources into a virtual network that we define in the cloud. VPC resembles very similar to our Office network with subnets, firewalls, private zones, public or DMZ zones, and a lot more. We can also create a VPN connection between on-premises and cloud environment through this VPC. And Route 53, it is a scalable and highly available domain name system web service that helps to route the end users to the internet application. Now AWS is a domain registrar as well, and here we can buy domain names for our organization and use them to mask the IP addresses behind it. And by the way, if you didn't know already, DNS is the one that translates human readable names like www.xyz.com into the numeric IP address. Let's talk about Developer Tool Services. Now, Developer Tool Services in Amazon provides services where developers can store an application source code and automatically build, test, and deploy applications on AWS, out of which AWS CodeStar enables us to quickly develop, build, and deploy applications in AWS. And Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. And Code Deploy, on the other hand, is a service that automates software developments to a variety of compute services, including Amazon EC2, Amazon Lambda, and even instances running on premises. And AWS Code Pipeline is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Let's talk about CodeStar. CodeStar is a service designed for developers where they can quickly deploy, build, and develop applications on AWS. AWS CodeStar provides a unified user interface enabling us to easily manage our software development activities in one place. With AWS CodeStar, we can set up our entire continuous delivery tool chain in minutes, allowing us to start releasing codes faster. And not only that, AWS CodeStar makes it easy for you or your whole team to work together securely, allowing you to easily manage access and add owners, contributors, and viewers to our project. And not only that, AWS CodeStar project comes with a project management dashboard, including an integrated issue tracking capabilities provided by Jira software. With the AWS CodeStar project dashboard, we can easily track progress across our entire software development process, from our backlog of work items to teams' recent code deployments, so on and so forth. AWS Code Build, on the other hand, is a cloud service that enables an IT developer to build and test code with continuous scaling. Now here, you pay only for the build time that you have used. Now Code Build is a fully managed service that helps compiling source codes and run tests and produce software packages that are ready to deploy. With AWS Code Build, there is no need for us to provision, manage, and scale our own build servers. Code Build scales continuously and processes multiple builds concurrently. So our builds are not left waiting in the queue because it's processed concurrently. Let's talk about security, identity, and compliance services available in Amazon. In general, the security, identity, and compliance services in Amazon helps us to maintain a secure environment in Amazon by providing services for user authentication, for limiting the access access to certain set of users on the AWS environment, out of which IAM, or Identity and Access Management, it's a product that enables us to manage access to AWS services and resources, that enables us to manage access to AWS resources and services in a secure fashion. Using IAM, we can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. On the other hand, KMS, or Key Management Service, is a managed service that makes it easy for us to create and control the encryption keys used to encrypt our data. And Cognito, it lets us to add user sign up, sign in, and access control to our web and mobile apps quickly and easily. And WAF, or Web Application Firewall, helps us to protect our web applications from common web exploits that could affect application availability, that could compromise security or consume excessive resources. And WAF, it gives us good control over which traffic to allow or block to our applications by sort of defining customizable web security rules. We can use WAF to create custom rules that block common attack patterns such as SQL injections or cross-site scripting, and we can also create rules that are designed for our specific application. Out of all the four, Identity and Access Management, it helps us to control access to AWS services and resources for our users. With the Identity and Access Management, I can restrict user access, or I can give a user complete access to the environment. If it's an admin, I can assign complete access, and if it is a user, I can provide some privileged access or less or degraded or no access depending on the role that the user plays in the organization. And KMS is a service that helps us to create and control the encryption keys used to encrypt the data. And also we can use hardware security model, HSM, to protect the security of our data in the cloud. Also, we can use hardware security model to protect the security of the key itself. And let's talk about the management tools and services available in Amazon. Management tools and services, it helps us to manage, monitor, and automate all the resources running in the AWS infrastructure, beginning with CloudWatch, a service which monitors the environment by receiving logs and creating a dashboard and sending alerts as needed, and CloudFormation, a service through which we can deploy new environments using just templates, and autoscaling, a product that lets us to handle the dynamic traffic with ease by dynamically scaling up and scaling down the environment as needed. And CloudTrail is another product or another monitoring tool that helps us to monitor or collect the logs of all the API calls to our environment and provides a searchable tool based on keywords and timestamps. Let's talk about CloudWatch a bit more detailed. Now, CloudWatch is a monitoring service for AWS. With CloudWatch, we can track the metrics, we can collect and monitor log files, we can also enable CloudWatch to set alarms and automatically react to changes in the AWS environment. CloudWatch can also monitor AWS resources such as Ec2 instances, Dynamodb tables, Amazon RDS instances, as well as custom metrics generated by your application and services and any log files your applications would generate. Now, we can use CloudWatch to get a system-wide visibility into resource utilization, application performance, and operational health. We can use these insights to react and keep your applications running smoothly. And CloudFormation, on the other hand, provides a common language for us to describe and provision all the infrastructure resources in our cloud environment. Now, CloudFormation allows us to set up and model all our AWS resources so that we can spend less time in managing those resources and more time on our application. Now, CloudFormation is really an infrastructure as a code service where I can build an infrastructure based on the portable template I might be carrying. Alright, in this demo session, we'll talk about how to install Jenkins on Amazon Linux Ec2 Instance. And before that, let's talk about what is Jenkins and what is the purpose of it, why it is used, and all that stuff. Now, what is Jenkins? Now, Jenkins is an open source automation server, and it provides a lot of inbuilt plugins for deploying and automating any project. In short, it's an continuous integration server, and it is used for many purposes, used for tasks that take care of continuous deployment and delivery. And it provides these advantages, like the developer now will not have to focus on fixing errors because errors are automatically handled by Jenkins, and because of that it leads to faster development environment. Alright, so how do we go about doing it? Let's get started. The first thing is to go to our console and launch an Ec2 instance. Actually, let me walk you through the steps through the PPT, and then I'll show it in the console. So let me first walk you through the steps in installing a Jenkins server. In this lab, we're going to launch an VM, or a virtual application server, to host our Jenkins installation, and then we are going to deploy Jenkins on top of it and then configure it as an build server. And for this we will need an AWS account to begin with, and then a bit of experience in Jenkins, and then some familiarity on EC2 and how EC2 gets connected to VPC, stuff like that. So when we're all done, this is how the architect is going to look like. Users, they get connected to EC2 instance, which is a Jenkins server, and then there are slaves, build slaves, that can be monitored, that can be used in deployment by the Jenkins server. So let's see how it is done. Alright, so let's first launch a server. Let it be an Amazon Linux instance. I'm going to pick T2 Micro because of the free eligibility, and because this is a lab, that should be more than enough. And I'm going to keep this as default. I'm going to stick with the default VPC, and I'm going to keep all the settings as defaults. And then I'm not going to add a storage. I'm going to keep the storage limited with the root volume. And then for security group, because we're going to access it through the internet, I would like port 80. In fact, since this is a lab environment, and since I'll be tearing it down right after the lab is over, we're going to use all IP, or we're going to use anywhere, all traffic, anywhere. View and launch. And I already have a key pair that I have created. If you're not familiar with creating key pair, launching EC2 instance, you might need to spend some time watching the AWS EC2 video. That would help. So I already have a key pair that's attached to this account in this region. So I'm using that key pair to launch the instance. Alright, and that's my Jenkins server. Alright, so once that is installed, let's log into it. Since this being an Linux instance, I'm going to use putty to log in, and then use the key pair that we have downloaded to log in. And the key pair was right here. Alright, now I'm connected to it. As first thing, we will have to install the Java environment. I'm going to show some commands towards the end. So if you're planning to do labs yourself, you can use those commands. They will be very handy. In fact, I can show it right now as we speak. So these commands are to install Java environment. And it has two versions as we speak, and I've chosen the latest version. So I've typed 2 and I've chosen the latest version in installing Java environment. The second is to install Apache Maven. Let me show you some commands that's used to install Apache Maven. And these commands vary from Linux version to Linux version. So if you're using a different Linux version, just be sure that you're using commands which are respective to that particular version. Right, let's install Apache Maven. Looks like some of them are already installed and it's throwing error for some, but anyway, it's considered an successful installation. And then let's install Jenkins. And the commands to install Jenkins is right here. So these are to install Jenkins, and to download the software and install it, and then start the Jenkins and make sure the Jenkins stays running even after a reboot. So let's run these commands. Alright, now Jenkins should be ready, or the Jenkins server is installed in our Ec2 instance and it is ready for us to access. And the default port is port 8080. So let me go to the URL or IP. Let me go to that and then try accessing it using port 8080. There you go. So at the moment it's locked. It requires admin password to log in, and the admin password is present in this particular folder and this particular file in the Linux instance. So let me get that. Okay, one moment. Looks like the admin password is not present. Just give me one quick moment. Okay, it's just a permission issue. Let me check the password in that folder again with the elevated permissions. There you go. There's my password. Alright, once we're logged in, we can install all the suggested plugins. Now that's going to take some time to run and install all the default plugins needed to run a Jenkins server. Alright, it's done. Now, as next thing, it's going to ask for the admin username and password. You can choose as an existing administrator, or you can also create another admin user. In this case, I'm going to create another admin user. Alright, so the Jenkins server is installed. We can use the similar but slightly different procedure on the Jenkins nodes or the slave servers to make them Jenkins slave and respond to the builds that we push, or receive the builds or receive the jobs that we push through this Jenkins server. So we have built this Jenkins server on Amazon EC2. A similar and slightly different procedures can be followed to build Jenkins build servers that can contact Jenkins server to receive jobs and start working. If you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. Everybody likes stories, so let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra, and he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem, and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure? Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire an resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in an organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give, a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hours, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. And if we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right. Instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it. And it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay-per-minute billing basis. All right. And at no point, because of the pay-per-minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent, regardless of whether you choose Windows or Linux. It's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators, so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application, instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances, or the number of VM instances in a scale set, can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and this skill set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The skill set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine skill set? Just like I said, this virtual machine skill set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability, or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment, where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now, functions are serverless computing. Now, many times if you've heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. All right, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, these Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It's very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of, so I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure CosmoDB. Now, Azure CosmoDB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure CosmoDB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure Cosmos DB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about Cosmos DB. So this Cosmos DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmos DB and the SQL database is that Azure Cosmos DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmos DB is it allows users to use key value, graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis cache. Discussion about Azure database won't be complete without we talking about Redis cache. Now, Redis cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis cache is based on a popular open source caching product, which is Redis, sometimes called as Redis cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis cache, this fast storage is located in memory with Redis cache instead of being loaded from the actual disk in the database itself. Now, this Redis cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis cache. And by using Redis cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis cache engine provides. So to summarize, this Redis cache, when we use Redis cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity, and not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now, this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now, this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now, these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment, or the appearance of the environment, or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending, or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are, by nature, separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps, or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling That's one advantage you get for content delivery network. That's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay as you go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us an boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage, or Store Simple, is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. You know, it has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this Data Lake Store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which has, or which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application, so it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates, or which kind of connects, or which kind of decouples both the environment. Now we have a queue in between, both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user's server's on-premises performance and capacity. and a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally so it's immediately available when needed. So that's some additional feature. I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he started, or he again started his discussion, but from a different angle now. So he started to explain what are the capabilities or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it has, or it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments. which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve, the certifications, the documentations, the stage-by-stage certification levels. It's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure. And they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now, right? So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. Alright, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. Right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. All right, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry. Take the dog for a walk. That's gonna get stored. I can create another entry. Book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app.
So what is Google Cloud Platform? It is a set of cloud computing services provided by Google that runs on the same infrastructure that Google uses to and for its end user products like YouTube, Gmail, and so on. Let's learn about benefits of Google Cloud Platform, such as high productivity, working from anywhere, quick collaboration, high security, fewer data stored on vulnerable devices, reliable resources which can be used across organization, across geographical regions, across countries, very flexible, which allows organizations to scale up and down as the demand rises or as the demand declines, and cost-effective solutions for various use cases. These are some of the benefits, and if we look into different services which Google Cloud Platform offers, we could look into detailed benefits which each service offers in a different use case, which basically helps organizations working in different domains, handling different kind of small, mid, or larger businesses, and with different business goals. When we talk about Google Cloud Platform services, here is a list of services, or I could say high-level domains or categories of services. So you have compute related services, you have storage and database, you have networking, big data, developer tools, identity and security management, Internet of Things, cloud AI, management tools, and also data transfer solutions. When we talk about Google's infrastructure, Google has one of the most powerful infrastructure in the world. The infrastructure is available in two levels, the physical and the abstract layers. You have physical infrastructure and then you have the abstract infrastructure. Physical infrastructure consists of data centers, extensive development of high efficiency backend data centers. You have a very strong backbone network which is used by Google itself and also offered as services to customers via GCP platform services. So you have global meshed redundant backbone network. Points of presence, when we talk about Google, it has 110 plus edge points of presence in more than 200 countries. And when we talk about edge caching platform at periphery of their network. So this is what defines the physical infrastructure of Google. Now there is much more to it rather than just these 4 points. When we talk about abstract infrastructure, that is divided in global, regions, and zones. When we talk about zone, a zone is roughly equivalent to a data center and a single point of failure. So you could have your compute engine, which is within a zone, or you could say compute engine is a zonal resource. You have regions, which are geographical areas which contain multiple zones. So you could have a region for US Central or Europe Central, Europe West, and so on. And within a region, you would have one or multiple zones, and zones basically would allow high availability of resources. So you have cloud load balancer as an example, which is regional resource. Then you have global resources, and they are available and shared across the planet. So you have various global resources such as network,
which could be even your IP addresses and so on. Now let's do a quick comparison of AWS vs Azure vs GCP, and let's look at what each cloud provider offers. Later we will also look into different services in detail when it comes to Google Cloud Platform, what each service does, what you can benefit from, which service should you use in what case. We will learn about those in later slides. If I compare your different cloud providers, when we talk about Amazon and its cloud offerings, that is Amazon Web Services or AWS as we well know it, Amazon Web Services has 69 availability zones within 22 geographical locations, and soon it will have 12 more in future. So this number keeps growing based on the spread of the services which a particular cloud provider offers. Here we are talking about availability zone specific information. When we talk about Microsoft's Azure, it has 54 regions worldwide and is available in 140 countries across the globe. When we talk about Google Cloud Platform is available in 200 plus countries across the globe. When we talk about virtual servers, Amazon's EC2, that is Elastic Compute Cloud, it is a web service which basically helps to resize your compute capacity where you can run your application programs on a virtual machine. So using EC2 service, you could launch virtual instances that could have any distribution of Linux, Windows. You could have different specifications when it comes to RAM or CPU cores or disk. You could also decide on what kind of storage a particular instance should use, whether the storage should be local to the instance or whether that should be an elastic file system or even an object storage. When it comes to Azure or Microsoft's offering, Azure Virtual Machine, that is infrastructure as a service, gives a user the ability to deploy and manage a virtual environment inside a virtual network on the cloud. And this virtual network on the cloud would be managed by cloud provider. Google Cloud or the offerings from Google Cloud Platform, that is GCP VM instances, enables users to build, deploy, and manage virtual machines in order to run different kind of workloads on the cloud. Now, when we talk about compute engine, here it would be good to discuss a little bit more about compute engine and what are the different options which Google Cloud offers. So when you talk about your compute engine, you have scalable, high-performance virtual machines. Compute Engine delivers configurable virtual machines which run in Google's data center with access to high-performance networking infrastructure and block storage. And you could select VMs for your needs. That could be general purpose or workload optimized. And when we talk about workload optimized, you have predefined machines or you have custom machine sizes. You can integrate compute with other Google Cloud services such as AI or ML and go for your data analytics. You have, when we talk about your GCP VM instances, just to expand on that, you have general purpose instances, which we call as N2, which provide a balance between price and performance, and they are well suited for most workloads, including line of business applications, web servers, and databases. Google Cloud also offers compute optimized instances, which we call as C2 instances, which offer consistent high-end virtual CPU performance, which are good for AAA gaming, EDA, HPC, and other applications. Now, when we talk about compute optimized or general purpose, how would we leave memory optimized instances? Those are M2 machines, which Google offers. So these offer highest amount of memory. These VMs are well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory caches. So if I would summarize this, when we talk about different instances, AWS also offers different kind of instances which are memory or compute or disk optimized. You have general purpose, and each category of machines has a different pricing model. You can always go to an AWS website, look for the pricing models, and that will give you an idea of on-demand instances or dedicated instances, reserved instances, and so on. Similarly, if you talk about Google Cloud also has instances with various options, which become the key features of why customers would choose Google Cloud Platform, such as live migration for VMs. So Compute Engine within your GCP can live migrate between host systems. And when I say live migrate, it basically means without rebooting, which keeps your application running even when the underlying host systems require maintenance. You also have preemptible virtual machines, wherein you can run batch jobs and fault-tolerant workloads on preemptible VMs to reduce your virtual CPU and memory cost by up to 80% while getting the same performance. So these are your preemptive or preemptible virtual machines. The only demerit is these can give you a really cost-efficient resource usage, however, can be taken off the shelf anytime. And that's why we call them preemptible virtual machines. You also have sole tenant nodes, which are physical compute engine servers dedicated explicitly or exclusively for users' use case. And when we talk about sole tenant nodes, these are usually good when you are dealing with or when you're working with your applications, which we call as bring your own license applications. So sole tenant nodes give you access to same machine types and virtual machine config options as regular compute instances. So there are different options which Google Cloud offers when it comes to these instances which we are talking about, and it takes care of different use cases in comparison to other cloud providers which are also offering these services, such as you can have predefined machine types, you can have custom machine types, preemptible VMs, as I said, live migration of VMs, you can use persistent disks, which could give you durable high performance block storage. You have local SSDs. You also have GPU accelerators, which can be added to accelerate computational intensive workloads such as machine learning, simulation, medical analysis, and so on. And you have features such as global load balancing, which makes Google Cloud a unique choice. When we talk about platform as a service, Amazon has platform as a service offering, which we call as Elastic Beanstalk. Among one of its services, it's an orchestration service for deploying applications and helping in maintaining these applications. Azure Cloud Service provides a platform to write the user application code without worrying about the hardware resources. Google App Engine is a service used by developers for building and hosting applications on Google's data centers. When we talk about serverless computing, so Amazon's AWS Lambda is a serverless compute service. It is used to execute backend code and scales automatically when required. When we talk about Azure, you have something called as functions, which allow users to build applications using serverless simple functions with a programming language of their choice. When we talk about Google Cloud, GCP has cloud functions, which is easiest way to run your code in the cloud, and it is highly available and fault tolerant. So in these days, when we are talking about microservices architecture, which organizations are preferring, when we are talking about organizations which can scale, which can dynamically change their underlying architecture, organizations would be interested in serverless computing, where they do not have to have a infrastructure set up, planned in advance before going for their use case. And this is where monolithic applications are really not a preferred choice. A lot of organizations are decomposing their applications into microservices based on business capability or decomposing based on subdomains. We can learn about microservices architecture later, but just to know that serverless computing, which basically helps any organization, if, for example, if you have a web application that receives non-linear traffic, and you cannot keep an eye on your server always. It would be good to have someone to auto scale your application. Serverless is basically a computing model where cloud service provider is responsible for managing the piece of code without the developer having to bother about infrastructure setup, management, maintenance, and so on. Now, when we talk about applications being serverless or benefiting from serverless computing, one of the key things would be zero administration, so deploying application without any provisioning and management. Auto scaling capability, that is, let the service provider worry about scaling the application up and down. You have pay per use model, which any customer would want to benefit from, that is, pay only for the resources that you have used or that you are continuing to use, right? Shorten the time between idea implementation and deployment, and this is something which any organization would want, that you would want a faster bring to the market solution timeline in comparison to getting entangled with deployment, management, and maintenance of your underlying infrastructure when your applications are facing a high demand. So when we talk about serverless, it is a function as a service, because each part of your application is divided as functions and can be hosted over multiple service providers. You have serverless apps, which are usually divided as separate units or functions based on functionalities or domains and so on. So serverless computing is gaining quite popularity these days in comparison to the traditional three-tier architecture, where you had a presentation layer, you had an application layer, you had a database layer. Now that kind of infrastructure is not really preferred in today's modern times when organizations are working on different kind of newer applications. When we talk about object storage, Amazon has simple storage service, that is S3. It provides object storage, which is built for storing and recovering information or data from anywhere over the internet. Azure comes up with blob storage, that is binary large objects storage, offers large amount of storage and scalability. It stores the object in the tiers and depending on how often the data is being accessed. Now same thing applies to even S3, which is from Amazon. So S3 also has different kind of storage classes which can be selected when a user or an organization intends to use a storage service. And when I speak about storage classes, it basically means having a frequent access storage or a infrequent access storage, or what we call as just an archival solution. Google Cloud has cloud storage, and it provides unified object storage for live or archive data. This service is used to store and access data on GCP infrastructure. When it comes to advantages, Amazon Web Services has enterprise-friendly services, easy access to resources, increase in speed and agility, and that too on demand, and takes care of your security and reliability of resources which are offered. When it comes to Azure, it has better development operations, strong security profile, provides a lot of cost-effective solutions, and operation execution friendly. When we talk about Google Cloud, one of the key features here is better pricing than competitors, live migration of virtual machines, which really interests a lot of organizations would want to modernize their infrastructure without having any kind of disruption in their existing services, improved performance, redundant backups, and so on. When it comes to disadvantages, in AWS, you have limitations when it comes to EC2 service. Well, there are different options in the kind of machines which you can choose, which you can work on. You have a technical support fee, which is incurred, network connectivity, and then also downtime, which might be in case when you're migrating. Azure, it has different code base for cloud and premise. Platform as a service ecosystem is not really as efficient as infrastructure as a service. Poor management of GUI and tools, integrated backup. When we talk about Google Cloud, support fee is quite hefty. It depends on what kind of solution or support you would or organization would be interested in. It has a complex pricing schema, although it has different use cases for which any user or any organization can benefit from. Downloading data from Google Cloud Services is an expensive option. Storage might not be. However, uploading data or downloading data would be an expensive option. When we talk about Domino's Pizza use case, now while we were discussing about these features, I would really want to spend more time in discussing each of these features or services in detail, such as you have compute engine, you have storage, you have Bigtable, you have Dataproc, and so on. So there are a huge list of services. Now, before we get into your Domino's Pizza use case, let me show you this page on Google Cloud where you can look at different services. So if you go to cloud.google.com and if you look at get started option under doc, so here you can find build solutions, look at different use cases, learn from basics of what is your Google Cloud, what are cloud basics. Then you can look at different cloud products. So here you have products in different categories such as AI and machine learning, API management, compute, containers, data analytics, databases, developer tools, and so on. And you can always click on any one of these to look into different solutions which are being offered, what are the different use cases, what are the best practices when it comes to migrating VMs to compute engine or operating containers or building containers and so on. You can always look at featured products, and that gives you a quick snapshot of what are the different products, such as you have compute engine, you have Cloud Run, BigQuery, which is a data warehouse, you have Cloud SQL, which is a managed MySQL or Postgres, you have cloud storage to basically push in any kind of data there, you have security key enforcement, AI and machine learning, and so on. So you have different featured products. Now, if you scroll down to the lower end of this page, you can again look at different solutions, and that would be really interesting to read and learn from. So you have infrastructure modernization, you have application modernization, you have data management, and so on. So if I look at infrastructure modernization, you could basically look at the solutions which Google Cloud offers and what it does when it comes to having your infrastructure modernized or benefiting by integrating with cloud and having immediate benefits of infrastructure modernization. You can look at different use cases, what they are doing, how Google Cloud really helps when it comes to migrating the workloads to a cloud, and how your different cloud solutions such as VM migration, you have SAP on Google Cloud, VMware as a service, and so on. And you could learn from these different solutions which are offered. You can also look at application modernization. So not only infrastructure modernization, but organizations would also be interested in relooking at their applications, relooking at how these applications could be moved from monolithic to microservices architecture, or how applications can benefit from modernization and cloud computing offerings. So you have again different use cases here, which talks about different ways in which Google Cloud can help, how you can modernize your applications, how you can use different solutions which Google Cloud is offering. Now, when we talk about cloud computing services, you can always go into cloud.google.com. If you have created a free account, then you can just log in, and every user by default gets a $300 free credit, so wherein they can try out different products, where they can use different services. So here, if I click on console, where I'm already logged in with my Gmail account or my Google Cloud account, wherein I have $300 free credit, out of which some is being used. You have a Google Cloud console, and here from the hamburger menu, you can click and you can look at different services within different domains. So you have compute domain, which has different services such as app. You have compute engine, and that basically allows you to use your VM instances, which we were talking about previous slides. different instance groups, create your templates, use sole tenant nodes, create snapshots or backup of your data, use different zones. You can go for Kubernetes, which is containerized based engine. You have cloud functions, you have cloud run, and then you have storage related different options such as Bigtable, you have data store, Firestore, file store, storage, and so on. And for each of these services, you can read about from the Google's documentation, or anyways, I will be explaining that later. You can also look at networking related, operation related, and other tools which are offered by Google Cloud. So these are huge list of services which Google Cloud Platform offers in different ways for different use cases. Now, let's look at this Domino's Pizza use case and see what it helps us learn about. So you can always access this page by going to this link which talks about customers and then which shows you different use cases. So Domino's increasing monthly revenue by 6% with Google Analytics Premium, Google Tag Manager, and Google BigQuery. So this is basically when Domino's started using GCP and what was the result of that. Now let's look further into this. So we all know that Domino is most popular pizza delivery chain operating across the globe. But how was that possible? Let's take a look. So the challenges were they wanted to integrate marketing measurement across various devices, connecting CRM and digital data to create a clear view of customer behavior, to make cross-channel marketing performance analysis easy and efficient. Now, for these challenges which Domino's was facing, the solution was using Google Analytics Premium, Google Tag Manager, and BigQuery, which were used to integrate digital data sources and CRM data. Reporting was made easier and more efficient by implementing Google Analytics Premium because it had the ability to access a single Google Analytics account to evaluate web and app performance. By using the new Google Tag Manager implementation, Domino's were able to act fast. They were able to connect CRM data with digital analytics, which basically provided Domino with greater visibility on customer behavior. What was the result? There was an immediate 6% increase in monthly revenue, 80% of costs in ad serving and operations were saved, increases agility with streamlined tag management. They obtained easy access to powerful reporting and customized dashboards. Now that was just one simple use case. Before we go on to hands-on, we can also talk a little bit back about these services which Google Cloud offers, as we discussed, and some of these services which can really make you think, why not Google Cloud Platform? So when we talk about your different cloud platform services, let's learn about some of these services in brief, in what each service is, what it does, and how it can help us in handling our use cases or working with different products. So let's learn briefly about different services which Google Cloud Platform offers. Now, one of the domains is compute, and then let's look at the compute services which GCP offers. Now here I can log into the console, and this hamburger menu on the top left corner, I can click on this one and go into the compute engine section. So this is the compute domain, which has app engine, Kubernetes engine, cloud functions, and cloud run. So these are your different services which are offered within the compute domain. And here we can get into compute engine by clicking on this one and then basically going to VM instances. So before we see how we can use this compute engine, let's understand about some of the features of compute engine, which basically offers scalable, high performance virtual machines, which are configurable and which runs in Google's data center with access to high performance networking infrastructure and block storage. So from here, you can select VM for your needs, for your general purpose or workload optimized, predefined or custom machines. Now here you can integrate compute with other Google Cloud services such as AI, ML, and other data analytics services. You have different machines which are offered here, such as general purpose, which provide a balance between price and performance, which are well suited for most workloads, including line of business applications, web services, and databases. You also have compute optimized machines, which offer consistent high-end virtual CPU core performance and which are mainly good for gaming, EDA, high process computing, and other such applications. Apart from general purpose compute optimized, you also have memory optimized machines which offer highest amount of memory, and these VMs are basically well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory cache. Now we can see these options here. You can click on VM instances while you're logged in into your Google Cloud Console. Here you can even create an instance template which can be used to spin up instances. For example, if I click on new VM instance from a template, there are some templates which I have already created for my usage. Now here I can basically use one of these templates, or what I can do is I can go back, I can go into instance templates, and this basically allows me to create a template. So you can click on create instance template, which basically allows you to create templates which can be used to spin up different instances. We can give a name to the template. For example, we can say template instance. Now here I can choose machine configurations, and this is where you have different options. So you have general purpose, as I mentioned, which provide a balance between price and performance. You have memory optimized, which are large memory machine types for memory intensive workloads. You also have compute optimized, which basically give you high performance machine types for compute intensive workloads. So you can choose any machine configuration which is available here based on your requirements. Now if you click on general purpose, that has different options here. So you look into the series where you have N1 series, you have E2, which are CPU platform selection based on availability, you have N2 and N2D. So let's just have N1 selected. Now you also have here which talks about machine types, and here we can choose the configuration which we are interested in. Depending on the applications which will run within the machines, we can choose a machine. So by default, it shows one virtual CPU core and 3.5 gigabyte of memory or RAM. You could choose a higher end machine. So as of now, I'll just say N1 standard. Now that basically allows me to choose these machines. So there are different features which your compute offers, such as you have live migration for VMs, you have preemptible virtual machines, you have sole tenant nodes, and all those options can be seen here. Now in this machine, for my boot disk, I can select a distribution which I would be interested in. For example, I could be going for public images, and I can choose, for example, Ubuntu. And then I can choose a version. So it shows me 16.04. And you also have latest versions such as Ubuntu 20. You can choose one of these. And here it asks you to choose the boot disk type. So that could be standard persistent disk, which is HDDs, which are low in performance and you can say low in cost in comparison to SSDs. So SSDs give you better performance, but then they are a little expensive than using standard persistent disk. We can choose this and we can give a disk size, for example, 20 gigabyte, and I can click on select. Before clicking on select, I can click on custom images, and that shows me if you have any other images created in your project, you could use those. You could also learn about images by clicking on this link. So we'll click on public images. We have chosen this distribution. Let's do a select. And now here you have identity and API access management. So let this be default. You can say allow default access. And what you need is, depending on the services, we can choose it allows HTTP and HTTPS traffic. Now, we would also need some way to connect to these machines. So when you set up an instance, by default, you can do SSH into it using the Google Cloud Console or from Cloud Shell. You can also give a private and a public key. So here you have the option where you can give all these details. So when it comes to management, it tells you would you want to go for reservations, and you can say automatically use created reservation. You could also say no, you would not want to use a reservation. You can also set up or provide a startup script which you would want to give whenever your machines come up. And here you have the options of preemptibility. So compute offers preemptible virtual machines. So that is mainly when you would want to run batch jobs and fault tolerant workloads on these machines, and you can benefit with a reduced cost for your virtual CPU and memory by 80%. So these are virtual machines which would be lasting less than 24 hours. Now by default this is off, and it purely depends on your workload, what you would want to run on these instances. I could just go ahead and select preemptible being on that and use this feature of compute. You also have on host maintenance, which talks about what would be happening with this compute engine instance. So when compute engine performs periodic infrastructure maintenance, it can migrate your VM instances to other hardware. And this is one of the features which compute engine offers, which we call as live migration for VMs. Here, your compute engine can live migrate between host systems, that is the underlying systems on which these VM instances are based on, without rebooting, which will keep your application running even when host system require maintenance. And here it says migrate VM instance recommended, and let that be as it is. You can also say that if there is a maintenance happening, you can terminate the VM instance. Now, it also talks about automatic restart, which is on, which basically means compute engine can automatically restart VM instances if they are terminated from non-user initiated reasons. So these are all the settings which are available in management, and it also tells us the different features which we have. There is also a feature called sole tenancy, which basically means sole tenant nodes which can be chosen. So you can have physical compute engine servers dedicated exclusively for your use, and this is usually good when you're talking about bring your own license applications. So sole tenant nodes give you access to same machine types and VM configuration options as regular compute instances. However, these might be a little expensive. We can choose this one. We can also look into networking, which basically shows the default setup, which goes for auto subnet. You can also choose a particular IP if that is required, but that would cost more. You can click on disks, which talk about what do you want to do with the boot disk when the instance is deleted, what is the encryption mechanism you would want to use. And here, finally, you have security. So basically, as I said, you can SSH into instance using the Cloud Console option, and you can also provide a public SSH key. So one way of doing that, if you intend to use an external SSH client such as PuTTY to connect, you can create a key. So for example, I can go into PuTTY gen, and here I can say generate, just move my cursor over here, and that will create a key. I can give a name to this one. So I'll say SDU will be username. I'll give a simple password, which I will use to log in to this machine. And then I can save this private key, which will get saved. So let's say SDU new key, and this gets saved in a .ppk file, which is usually used when you use an external SSH client to connect. So save this one, and that saves a ppk file on your desktop. What you can also do is you can copy this public key content from here, and this is what we would want to give in our instance here. So that the public key gets stored on the instance, and private key is what we will use to connect. So once I paste it here, it resolves the name to HTU, and we have given the public key. Now in certain cases, you may want to use a software which uses SSH to connect to the machine, and that software might not be such as your PuTTY. So in that case, you may want a PEM file or a private key which is saved as a .pem file. So you can also do that by going to conversions and do a export OpenSSH key and then save it. So I'll say HDU new key, but then this one will be saved as a PEM file on my machine. So you have ppk file, which allows you to use PuTTY to connect to the instance. You have a PEM in case a software needs directly SSH to these machines. You also have the public key, which we have already provided in the machine. Now, once this is done, I can close PuTTY gen, I can go back to this page where I'm creating an instance template, and then I can just click on create. So this has created an instance template which I can use to spin up my instances, any number of instances using the same template. Only thing which I would have to do is change the region where I would want the instance to run. So now that we have created instance, and that's this one, the third option, I can go back to VM instances. Now I can click on create, and here I can either create an instance from scratch by giving all the details again, or I can just use my template. So I can click on new VM instance from a template, choose my template, click on continue. And once this is done, I can give my instance name. So let's say C1. I can choose the region. So I will choose Frankfurt, and then rest everything is auto populated based on the template what you have given, and you click on create. Now this basically allows you to spin up an instance, and you can create any number of instances using your template. You could have already created a new instance right from scratch. Now once the instance is created, this has a public IP and a private IP. Private IP will not change unless you would want to set up a new machine, but public IP will change every time you stop and start the machine. Now this is what we need to connect to this machine. I can also do a SSH from here by doing this and open in a browser window. Let's click on this. So this is an internal way of connecting to your instance using SSH. Let's wait, because it would be transferring the SSH keys to the VM. It establishes a connection, and I'm connected to my machine. What we can easily do is to confirm if we are in the right machine. We can just do a ls to look at the file system. What we can also do is we can basically log in as root by doing a sudo su, and that allows you to get into the machine as root. And from here I can switch to HDU user, which will have a .ssh directory in home, and that basically has authorized keys. And if we would want to see if this one contains my public key, I can just do a cat.ssh and then look into authorized keys, and this shows me the public key which we had initially added to our instance. So this confirms that we are logged into the machine which we created. Now I can close this, and what I can also do is I can copy this public IP. So let's do a copy to clipboard. Now go to putty, and here I will say host name, where I'll say HDU, give my public key. I'll click on SSH, and in SSH I'll go to authentication. Now here we need to give our PPK file. So the PPK file was HDU new key. Select this one, come back here, come to the session, give it a name, for example C1, save it, and then you can just say open and say yes, and you are logged in to your machine. Now once you're logged in, you can always do a -ssh, and that shows you the file. So this is how you have just used the compute engine to spin up an instance, but we used a template which basically allowed me to create this instance, and then I can connect to this instance, and then I can start working on this. So when we talk about features of compute engine, it has predefined machine types as we saw. So compute engine offers different predefined virtual machines, and they have configurations for every need, from small general purpose instances to large memory optimized instances with up to 11.5 terabytes of RAM. You can have fast compute instances optimized up to 60 virtual CPU cores. You also have custom machine types, so you can create a VM that best fits your workload, and by tailoring a custom machine type to your specific need, you can realize significant savings. There are preemptible VMs, which we saw. There is also a facility which allows you to take the benefit of live migration. For VMs, you have durable high performance block storage for virtual machine instances in the form of persistent disks, where data is stored redundantly for integrity, flexibility, and to resize storage without interruption. And you could be choosing HDDs or SDDs for your instances. Now you also have options such as GPU accelerators. So for example, if I just click on create instance, and I can look into that. So here, let the instance name be instance 1. And what I would be interested in looking at this one, which says CPU platform and GPU. So CPU platform configuration is permanent. You can also do add GPU. So GPUs can be added to accelerate computationally intensive workloads like machine learning, simulation, medical analysis, and virtual workstation applications. So you can add and remove GPUs to a VM when your workload changes and pay for GPU only while using. So these are some of the features which basically Compute Engine offers, and we already know that Google bills in second level increments, so we only pay for the compute time. Now there are different savings which are possible. So you have commitment savings, which basically means you can save up to 57% with upfront cost per instance type lock-in. You have container support, so you can basically run, manage, and orchestrate Docker containers or Compute Engine instances. So here, when we are setting up our instances, there is an option which basically allows you to use or deploy Docker images. Now that can be done. You can also benefit from sustained use savings, that is sustained use discounts, which are automatic discounts for running Compute Engine resources for significant portion of the billing month. You can create a reservation for VM instance in a specific zone, which is basically seen under your management section here, and you can ensure your project has resources for future increases in demand, and if no longer needed, delete the reservation. So these are some of the features of Compute Engine. What we have done is we have created Compute Engine using the console. Now you can go back. You can also do that using Cloud Shell, and you can click on this one which activates Cloud Shell. You could also have the Cloud SDK support set up on your machine, which can be used. Now I can just open this in a new window, and from here I can start giving commands if I would be interested in setting up an instance from my command line. So here you have different options. Now to begin with, you can just do a G Cloud and just hit enter, and that will show you different options which are available, which can be used. So you have G Cloud Compute here, which shows an option to create and manipulate Compute Engine resources. Now I can just do a Q to quit. I can do G Cloud Compute, and that basically will again show me different options which are available if you would be interested in setting up instances from the command line. So here I can say G Cloud Compute and then go for instances. And if you do not know the commands, you can just hit enter. That will show you all the different options which we have. So here we have different options such as list or create or start or update. For example, I can just do a list here to see what instances I have. And the instance which we just created shows up here. It says that status is running. I can just stop this instance. I can delete this instance. I can even create an instance by using a create command here, and you can just do a create help, which will show you what are the different options you can give. So it says instance name is what you need. You can choose an accelerator, you can choose the boot disk, and various other options. So I can just say create, and then I can give a name, for example C2, and once I click on this one, it says, did you mean Europe West 4 zone? So it is asking me for the region and the zone, and I can say yes. And these settings are coming from my default profile. I can always change those by changing the metadata. So now we have created an instance. It says running. If we do a list again to see, we see 2 instances created. One was in Europe West 3, one was in Europe West 4. Both of them have internal and external IPs. Now you can do a describe to look at the different options here. So G Cloud basically allows you different commands which you can use to work with your instance, to create instances, to change the metadata. If you would want to change the region, if you would want to add a startup script, all those options are possible from the command line, which we can learn in detail in later sessions. So this is your Compute Engine as a service. Now that we have learned about the compute domain and compute services which is offered by GCP, Let's also learn about storage and databases. That's again within the storage domain and the services which are offered by Google Cloud Platform. Now you can go back to console, and here you can click on this one, and here you can just scroll down to see what are the different options in storage. So you have options such as Bigtable, you have data store, Firestore, file store, you have SQL based services, you have storage, which is object storage, and then you have other options which are available. So Google Cloud Platform offers different storage based services, out of which storage, which is your object storage, is quite popular one. Click on storage, and that basically shows you an option which talks about storage browser. So this is your Google Cloud's object storage. So when we talk about object storage, it is basically a storage where you could store any kind of data. And when we talk about object storage, it is a bunch of bytes which we address, wherein every object will have a unique key. These unique keys are in the form of URL, which allows you to access the object. So cloud storage is comprised of what we call as buckets, which are used to store and hold your storage objects. These storage objects are immutable, and every change creates a new version. Now you can also have control access via IAM, that is Identity Access Management, or via Access Control List. So there is also an option called object versioning, which basically says if it is on, every time you try to store the same object, a new version of the object would be created. Otherwise, newer option will override old one, as we cannot archive the old version. So let's see how we work with this object storage. So here you can click on create bucket. Now once you click on create bucket, it needs a name. So let's say test bucket, and here I can just give say number 1. So that says this is the name of my bucket. Now I can directly click on continue, or it would be good to look at different options which are available here. So when you click on choose where to store your data, so it already gives me an option. It says the bucket name is already taken. So let me give it a unique name. So let's say test buck, and let's call it AUA. So that should be unique. Now here it says choose where to store your data. So this one gives you location type. So you can have region specific buckets which give you lowest latency, that is fastest response time within a single region. However, it does not make your storage highly available. You can make it dual region, which is basically allowing your bucket or storage to be accessible across regions. You can also make it multi-region, which is highest availability offered. As of now, we can choose region specific, and now it asks you to choose a location. Now, as always, I will choose Frankfurt. Now I can click on continue, and let all the storage options be default, or you can click on a default storage class. Now that tells you based on your storage class, there are variant costs when it comes to storing, retrieving, or doing any kind of operations. So you have a standard option which says best for short-term storage and frequently accessed data. You can also go for cold storage such as nearline, which is best for backups and data access less than once a month. You can go for freezing storage such as cold line, best for disaster recovery and data accessed less than once a quarter. Or you can go for archiving, where the data is accessed less than once a year. Let's go for standard as of now. And now you can choose how to control access to objects. So you have fine-grained or uniform. Let it be fine-grained, wherein you can give additional permissions at bucket level using IAM, or object level permissions using access control list. In advanced settings, you can choose the encryption, and you can also choose a retention policy. So a retention policy to specify the minimum duration that this bucket's objects must be protected from deletion or modification after they are uploaded. You can always learn about this more by clicking here. Now, once I've chosen all the relevant options, I can click on create, and that basically will create a bucket by the name I have given. I can click on overview to basically see brief details about my bucket, such as region, what is the default storage class, and it also shows you the link URL which can be used to access your bucket. It also gives you the link for gsutil. Now gsutil is a command which can be used in your Cloud Shell to basically work with your buckets. You can click on permissions to basically see what kind of permissions are already in place, and you can then make changes. You can basically add members, you can view by different roles. So for example, here by default it shows other services such as data proc or your bucket owner or bucket reader related permissions which have been already granted. Now, once I've looked at my bucket, I can start using it. I can drag and drop and push in files here. So as of now, there are no live objects in my object storage that is in my bucket. What I can do is I can click on upload files, and then I can choose a location from my machine. For example, I'll go into data sets, and what I can do is I can choose some of the files here in any format. Let's choose CSV or text and just to open. So this one will basically upload my data sets here. Now once I've uploaded the files, I can basically close this one. I can look into options here which says edit permissions, edit metadata, if you would want to download it, if you would want to copy, move or rename it, if you would want to export to a different service called Cloud Pub Sub, which is Publish Subscribing Messaging System. You can scan the data. Now you can click on a particular file, and that basically shows you the URL, which basically allows you to access this file. You can try copying this. You can click on download and download this file. You can even try accessing this from public, and that basically shows you the content of this file based on the permissions. So this is basically your object storage, which is one of the service which is offered. What you can also do is you can create folders, and within folders you can then upload your data. So this is your Google Cloud storage option, which is for your object storage. That is, you can add different items, you can give different permissions, and you can use this Google Cloud Platform's storage service offering. Now you also have other options such as Bigtable, and we can go into that by clicking here and click on Bigtable. So Bigtable is one of the service which kickstarted NoSQL databases. Today in market, we see different NoSQL databases such as Cassandra, HBase, MongoDB, CouchDB, Neo4j, and many others. So you can basically use Bigtable, which was the pioneer when it comes to your NoSQL databases, or not only SQL databases. So the problem initially faced by Google was that the web indexes behind search engine were taking too long to build. So company wanted to build database that would provide real-time access to petabytes of data. And that's where Bigtable began. So Bigtable powers different other Google services such as Gmail, Google Maps, and other services. And in 2015, it was launched as a service for customers. So when it comes to scalability, with use of Bigtable, you can increase your machine count without any downtime, and you can handle admin tasks like upgrades, restarts, and so on, which are basically taken care by the cloud provider. Data present in Cloud Bigtable is encrypted, and you can use IAM roles to specify access. So data written to or from Bigtable is through data service layers such as managed virtual machines, HBase REST servers, Java services, HBase client, and so on. Here, if I would want to use Bigtable, I can click on Create Instance, and that basically tells me Cloud Bigtable Instance is a container for your clusters. Now here you can give an instance name. So for example, I will say AUA and then say, for example, test, and let's say Bigtable. So that will be the name of instance. This will be permanent. You can choose the storage type. Again, you can go for lower latency, more rows read per second, typically used for real-time serving use cases, or you can go for SDDs, which have higher latency for random reads, good performance on scans, and typically used for batch analytics. So let's go for SSDs as of now. Here you have cluster ID, which is auto-populated. You can choose a region. So let's go for our favorite one here, where I can say Europe West 3. I can choose a zone here, and I can then choose how many nodes would I want to use for my big table. So when you talk about big table service, it will have a cluster underlying, which will have various nodes, which will control your data throughput, storage, and rows read per second. So as of now, let it be just one node, and that's enough for our demo. When we talk about performance, it basically tells you based on the current node and storage type, it tells you how many reads can happen at milliseconds. So it says 10,000 rows per second at 6 milliseconds. You have writes, which are 10,000 rows per second, or you have scans, which are 220 megabytes per second. Storage, which is taken care here, would be 2.5 terabytes. And I can then basically click on create. Now there is also some option called replication guidance, which basically says replication for cloud table, big table copies your data across multiple regions, enabling you to isolate workload and increase the availability and durability of your data. Depending on your use case, you can have big table, which can be used to have your data across regions. Now you can click on create with all your specifications chosen, and that's going to set up a cluster, or you can say a fully managed NoSQL database, which will give you low latency and replication for high availability. Now, once we have a new instance, you can connect to it with the CBT command line tool. And for instructions, you can click on learn more here. You can just click on this instance ID to see the details again if you would want to look into your big table setup. So it tells me here that we have one instance, what is the CPU utilization time, how many rows were read or written, what is the throughput, and this is auto-populated based on your usage. You can click on monitoring, and that basically will give you different widgets which will display information for your CPU utilization, what is your hottest node, depending on how many nodes you have, system errors, automatic failovers, storage utilization, and so on. You can click on Key Visualizer, which will allow you to look into your table if you have already created some data here, and you can click on Tables to see how many tables you have added here. So that's in brief about your big tables, which is one thing which we need to remember is it's not good for all use cases. So should be used for low latency access, that is fast access, and good if at least data is greater than 1 terabyte. For smaller amount of data, the overhead is too high. So big tables performance will suffer if you store individual elements larger than 10 megabytes. If you want to store bigger objects such as images, video files, then go for object storage, and that would be a better option. So always remember, big table is not a relational database, it's a NoSQL database. And when you talk about multi-row transactions or online transaction processing, big table is not the right choice. So it can be used for wide range of applications, especially when you talk about your OLAP, that is online analytical processing. So it is designed to store key value pairs, and there can be different use cases. So for example, if you are using something like Cloud Data Flow or Cloud Data Proc, where you would want MapReduce kind of operations, big table can act as a good storage because it has very high throughput and scalability. And the best thing is that it supports HBase API, thus allowing easy integration with Apache, Hadoop, and Spark clusters, which you can bring up using one more service which Google Cloud Platform offers, which is called Cloud Data Proc. So big table is good for real-time analytics. It's commonly seen in financial services, IoT, and others. And if you are thinking of running interactive SQL, then big table would not be the right choice, but the other choice would be BigQuery. You should also remember that this has a cluster running, and you would be charged if this cluster kept on running. So you have to be very careful in your free account when you're using such services. Now we have clicked on this one, so I can select this one, and basically I can look at the permissions, I can look at the labels, I can look at inherited permissions here. I can also click on my instance which we created, and either you can edit or you can just do a delete. So as of now, we will just delete this, which needs you to give in the name. So we'll say AUA test BT and then click on delete. So whenever you're trying out different services, the first approach should be setting up these different services, seeing how they work, basically trying connecting to them. And once you are satisfied with the initial test, then you can plan your actions and come back and use the service for a longer duration. Now that's your big table, which is one of the offerings. We can go back into storage, and here you have other options which are available. So for example, we were in big table. You also have an option such as cloud data store. Now that's one more service which is offered by Google Cloud Platform when it comes to storage domain. So Google added software on top of big table which supports more than simple key value pairs. When you talk about secondary indexes, instead of just having one primary index, when you talk about asset properties for reliable transactions such as SQL query like language, so these features or these services were added to or on top of your big table, which gave birth to a new service which was released as Cloud Data Store. So this is where you have Cloud Data Store, and you can select a Cloud Firestore mode. So you can go for a native mode, enable all Cloud Firestore's features with offline support, or you can go for Cloud's data store system on top of Cloud's Firestore. So these are different options here. And here we look at the API or scalability, engine support, how many writes it supports, and so on. You can choose one of these, and then you can choose where to store your data. So for example, if I click on this one, then it asks me to choose a location. So it says the location of your database affect its cost, availability, and durability. Choose a regional location, lower write latency, lower cost, or multi-region location. Here I can basically choose, for example, Europe, and then I can go ahead and create a database. So it says initializing Cloud Firestore in data store mode services in EU3. This usually takes a few minutes. You'll be redirected to your database once it is ready. So if we compare the pricing structure between Cloud Data Store and Cloud Big Table, always remember Cloud Data Store, you pay for monthly storage, which is also in the case of Big Table. However, here you are paying for monthly storage for reads and writes. But in case of big table, you are paying for cluster when it is running. So Cloud Data Store is a good option for small data, infrequent access, and it acts cheaper. When you talk about large amount of data or big data and frequent access, then you're talking about Cloud Big Table. So Big Table is cheaper when you talk about larger amount of data. So here it says, since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. You could do that. You could learn. You could say query by GQL. As of now, we don't have any data here. Let's look at the dashboard, which says since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. So this is your Cloud Data Store, and it has many features which help you to work with your data. However, some features or important features of RDBMSs were still missing, and that's where Google created yet another big table based service called Cloud Spanner. Now we can continue working on Cloud Data Store, which basically gives you one option to work with your data. You can create an entity here by clicking on Create Entity, and that basically gives you options such as default namespace. You can give a kind, you can give numeric ID, and you can start adding properties. But to learn more about data store, we will learn about this in further sessions. So as of now, I'm going to click on cancel. I'm going to go back to my data store, and this basically, let's go to data store option, or I can go into admin here, which basically says if you have entities, you can import or export them. So let's go back and let's again look into storage options. So as of now, we were in data store. Let's click on this one. So as I mentioned, your Cloud Data Store, which basically gives you some additional features on top of your big table. But what Google also did was it realized that there was a need for RDBMS feature support. That is, there were a lot of features. Now here we have created a data store and it says your database is ready to go. Just add data. You can create entities, start putting in data, and then you can go ahead and query this. So if you would want to learn more about your data store, you can just click on this one, and that takes you to the complete documentation of native mode and data store mode. What is Firestore in native mode? What is in data store mode? What are pricing and locations? How you choose a database mode? What are the feature comparisons? What you can do, what you are allowed to do here, what programming languages can be used, different regions, pricing, and so on. As of now, we'll click on this one and let's look at one advanced service which Google Cloud came up with when it comes to your additional features of RDBMS. So Google created yet another big table based service called Cloud Spanner. Now that you might not see here, but if you scroll down, you should be able to see your Cloud Spanner in the options here. Or did we miss it on the top? So let's again look here. Yeah, so it is here and you can click on Spanner. So Cloud Spanner was released in 2017. It basically supports relational schema. So it offers strong consistency for all queries, which can be SQL based. You can have multi-region deployment. Now, when it comes to massive scalability requirement and strong consistency, Cloud Spanner is a good option. So it says Cloud Spanner is a managed, mission-critical, globally consistent and scalable relational database. So if you would want to use this, then you will have to enable this API, which shows you an option here. It says try this API. So it's a managed service. So it is one of the Google's most expensive database services. There is also one more database service, which is Cloud SQL, which can be used. So when we talk about your Cloud Spanner, it is fully managed relational database service. It is massively distributed. You can have millions of machines across hundreds of data centers with support automatic sharding and synchronous replication. It gives you low latency and schema updates without downtime, making data high availability and reliability. So we'll learn about Cloud Spanner with more details later in other sessions. Now, we can also go back to storage and we can look at the different options which we have here. So you have object storage, you have Spanner, you also have your SQL based service, which is yet another managed service offered by Cloud or Google Cloud, I would say. So that's called Cloud SQL. So this is basically a service which allows you to have fully managed relational MySQL, Postgres, and SQL Server databases. Google handles replication, patch management, database management, and other things which are related to this managed or fully managed database service. It can allow you to handle terabytes of storage capacity with 40,000 IOPS with huge amount of RAM per instance. So you can click on create instance here and then you can choose one of the database which you would want to use. So Cloud SQL is a managed service. You can choose one of your MySQL or Postgres and SQL Server. Say for example, I choose MySQL. Now that basically tells me what is the instance ID. It sets up a password. You can always change the password. You can change the region. You can choose your database version. And then you can also look at other configuration options which talk about machine type, which will be used, what is about your backup and recovery, maintenance, and all that. And if you click on create, this will basically create a fully managed SQL service, which can allow you to straight away start using MySQL on cloud, thus allowing you to store your relational data. When we talk about storage options, how can we not talk about a data warehouse solution, or basically an option which allows you to run your queries by directly updating data? So you can use a data warehouse service which Google Cloud Platform offers, and that's called BigQuery. So basically you can be looking into the big data section here, and here you have an option called BigQuery. So this basically brings ease of implementation and speed. So building your own data warehouse can be expensive, time consuming, and difficult to scale. So with BigQuery, you just load data and pay only for what you use. So when it comes to features, you have features such as capability to process billions of rows in seconds. And if you would want to do real-time analysis of streaming data, that is also possible here. So here we have clicked on BigQuery, which basically shows you the option where you can start typing your query and test your data access. For example, if I have uploaded some data, so it shows me there are some queries which are saved here. Now I can schedule a query. I can basically choose the format of a particular query by clicking on this more. Here I have an option which says add data. So I can pin it to a particular project. I can explore public data sets. I can create a connection. So if I click on explore public data sets, then it takes me to a page from where you can get different kind of data sets which are already available, which you can put into your BigQuery and start querying your data. By default, it shows that it is aligned to my project and I don't need to worry about it. I can look at saved queries if I have already saved a particular query. I can look at job history. I can look at transfers, scheduled queries, and reservations. So BigQuery basically initially had its own version of SQL, which was slightly different from standard SQL. But in 2016, BigQuery 2 was released that supports SQL 2011 standard. You can always select standard SQL. Now BigQuery, when it comes to pricing, we need to remember that the storage cost is very less here, approximately 0.02 cents per GB per month. It is almost similar to Nearline, where you can also have low cost, that is 0.01 cents per gigabyte per month. There is no charge for reading data from storage. When it comes to querying, and that's where the cost is incurred. So 1 terabyte per month is free, and after that it costs few cents per gigabyte. So this is mainly for high volume customers. There is a flat rate pricing which can be used. So when you talk about querying, you can save your query results. You can create data set to store the results. Now results are put in a temp table in cache. And after you're done with that, you can delete data set and delete all the data. So when you talk about loading data into BigQuery, you can get the data from cloud storage, Google Drive, Cloud Data Store, Stack Driver, Stack Driver other options. You have Cloud Bigtable or other web interfaces. So you can download from URL such as CSV, JSON, Avro. You can create dataset, create table, and create from source by doing a file upload. So 10 megabyte or less files can be uploaded using web interface. As an option, you can also use command line, and then you can start working with your BigQuery. So here you can also work with streaming data by basically pushing in streaming data into your BigQuery, which allows you to add one record at a time. Now you could use something like Cloud Data Flow, which allows you to use a particular pipeline. About Cloud Data Flow, we will learn later. So you can benefit from different features of BigQuery and thus use Google's offering to work on your structured data, or I would say data which suits well in data warehouses. Now, these are some of the storage related services which Google Cloud offers. Although we will learn about using BigQuery and running or uploading some data by creating add data set here, by say creating connection or using a public data set. So as of now, I have this. You can also access the command line to work with this, but we will learn in detail about BigQuery in later sessions. Now here you can scroll down and you also have an option within big data space, and that is your data proc. So when you talk about data proc, this is again a managed service which allows you to run Spark or Hadoop jobs. So especially if you are interested in big data workload. So for big data processing, for machine learning, you can always use Cloud Data Proc. This uses compute engine instances under the hood, but takes care of management of these instances. So it's a layer on top to spin up clusters. It's a managed service. It's cheaper, pay when the jobs are running only. It's fast because it is integrated with other Google Cloud services. You have open source components pre-installed, and Dataproc is integrated with Yarn to make cluster management easier. When you talk about Dataproc, you can click on create cluster, and that basically allows you to set up your cluster by choosing a particular region which you would want to use. For example, I'll choose Europe West 4. Here it tells what kind of machines you would want to use, and by default it has populated as the machine here, which is 4 CPU and 15 gigabyte. Now, since you might be using a free account, let's not go for the high-end machine. Let's go for N1 standard 2, and then you can scroll down. It says what is the primary disk, what is the disk type, and this one was for your master machine. That is machine which will have the master processes running. Then you have your worker node configuration, which tells this will be, let's choose a lower end machine, and we can choose how many worker nodes you would have. So it says minimum 2. You can choose the SSDs and their capacity. It talks about Yarn cores and Yarn memory, which will be allocated. And here we have then option of clicking on create. So once you click on create, this will basically spin up a cluster wherein you can straight away start submitting jobs to this. You can basically go ahead, once your cluster is ready, you can go into the cluster, you can submit a job, you can choose a type which is Spark or any other application which you would want to run, and then basically you can use this fully managed service which allows you to run your big data clusters. You can obviously control access via roles or access control list, and you can have access as it is at project level or based on your Dataproc cluster or even at your worker nodes. So we'll learn about Dataproc in later sessions. So as of now, you see here, the cluster is getting created. It says the cloud storage bucket, which it is using, is this one. Now I can click on this and open link in a new tab. It still takes me into console, but now it is showing me the bucket which is being used by your Dataproc cluster. This is the bucket which is being used, and it is being used for underlying metadata which gets stored here. So you look at the cluster related folders, you can click in these folders and then it can see what is the script output, what it is doing, and so on. Now I can come back here to my bucket, which will basically show me what kind of buckets have been created. So you see Dataproc service automatically created some buckets which will be holding some data. You also have some other buckets which were created based on other services which we used. The access control is fine-grained in all cases, plus it also shows our bucket. So underlying, it is using compute instances. It is basically using, let's go here and let's go to compute engine and let's look into VM instances. So Dataproc, which has spun up a cluster, is also using the VM instances which we see here are running. It is using the buckets and it has made a cluster ready to use. So you can click on this cluster and that shows me my cluster related details, if there are any jobs running, what are VM instances, what kind of configurations it has used, and you can look at different details here. You can look at the logs, you can click on jobs, and that will show you if you have basically run a job on this ready to use cluster. So it says there is this particular job which was run, which was a Spark job. You can click on submit, and this one tells you what is the job ID, what is the region you would choose. For example, we will again choose, for example, Europe West 4. It tells what is the job type. So you can run all these type of jobs in this cluster, such as Hadoop, Spark, PySpark, Hive, Pig, Presto. You can give your jar file. So if you have packaged your application as a jar, you can mention that here. You can pass in some arguments. You can also say some other jar files, add some properties, and then click on submit, which will run your job on this ready to use cluster. Now, since we have tested it, I can basically go ahead and do a delete. I don't want to incur any cost on these managed services which are running. So there are a lot more information about using these services which Google Cloud Platform offers, and we can continue learning about these services as we explore your Google Cloud Console or even your command line option. Now, we can come out of this one by clicking on this menu, and then we have other options such as Kubernetes, you have Cloud Functions, you have your networking related services, monitoring related services, different kind of tools what you have other big data specific services which you can learn about. And for each of these services, Google has a very good documentation available. For example, when you talk about publish subscribe messaging system, it is a real-time managed service which basically is a pioneer which was used, and now you have a famous service such as Kafka which is being used for your publish subscribing or messaging system kind of requirements. So to conclude about Google Cloud Platform services, you can always go to cloud.google.com and look into the document section. Now here you have list of different featured products. You also have list of your different domains and services which Google Cloud offers, and you can learn about all the different services which are offered by Google Cloud. Here you can click on featured products, and that basically shows you Compute Engine, Cloud Run, Cloud Storage. You have Cloud SQL, BigQuery, Vision AI. You can scroll down and look at your artificial intelligence and machine learning related services, platform and accelerators, API management. So Google Cloud Platform offers different services mainly in your compute, storage and databases. You have networking related services, big data specifics, developer tools, cloud AI, identity and security, IoT management tools, API platform, and so on. So basically learn about the GCP services which Google Cloud Platform offers, and in detail you can play around with different services which are offered by creating a free account, and as I demonstrated, you can use any one of these services, quick start them, basically connect to them, put in your data, or use a managed service to manage your data and benefit from Google Cloud Platform, thus having modernized infrastructure for your different use cases.
With that, we have come to the end of this video tutorial on DevOps and Cloud Computing Full Course 2022 by Simplilearn. If you have any queries, please feel free to put them in the comment section of the video. Thank you for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.